So guys, what is storage? It is a device that saves the digital data for future use. So storage can be categorized in two types. We have two types of storage, you can say. One is direct attached storage, which is also called as DAS, and the other one is shared storage. Let us try to understand what is the difference between direct attached storage and shared storage. Direct attached storage, any storage system directly attached to your computer is directly attached storage, like hard disk, USB, SD card. Okay, so these devices which are directly attached to the computer, they are considered as directly attached storage. So the best example of DAS is your hard disk. Hard disk is directly attached to the computer. So guys, till now we have covered all the topics using DAS, using local hard disk. So we have covered the topics like how to create the virtual machine and other topics. So everything is saved on the local hard disk. Now from here we need the shared storage. Okay. So what is this shared storage? The shared, it is not same. Just 1 second, let me correct it. Yeah, it is correct. Okay, here the shared storage, what we do, we share the same storage with multiple ESXi. Okay, that is why it is considered as shared storage. In this example, if you see, we have ESXi1, ESXi2, ESXi3, and all of them are sharing the same storage here. Okay, that is why it is called as shared storage. So why do we need this shared storage when we have the direct attached storage? So we need this shared storage for advanced features like vMotion, DRS, fault tolerance, etc. So for performing the advanced features, we need the shared storage. Shared storage means we will take one storage and the same storage will be shared with the multiple ESXi hosts. Let us say data store 1. We have created data store 1, and this data store 1 will be shared with ESXi1, ESXi2 and ESXi3. So if these multiple ESXi hosts are sharing the same data store, then only we can perform vMotion, DRS, fault tolerance and other features. And you need to note one thing here. This shared storage is the external storage. External means it is not directly connected with the ESXi host. It will be the external storage like SAN or NAS. We will see what is this SAN, what is this NAS. But this shared storage is the external storage, which is not directly connected to the ESXi host. Guys, give me 2 minutes. Alright. So we share the same storage with multiple ESXi hosts to perform the advanced feature like vMotion, DRS and fault tolerance. Now guys, we have two types of shared storage. One is SAN, which stands for Storage Area Network. Another one is NAS, which stands for Network Attached Storage. We'll discuss about SAN first, then we'll discuss about NAS. So let us complete SAN first. So what is SAN here? SAN is a network storage device that can be accessed by multiple ESXi hosts or servers. In this example, if you see here, we have this SAN here, storage area network. In this SAN, we have multiple hard disks attached. Okay, and these hard disks, they will be shared with the multiple ESXi hosts. So this hard disk, they will not be shared directly. Okay, what we will do in SAN, we combine all the physical hard disks and we make one LAN. Okay, in this example, let us say we have 1, 2, 3, 4, 5, 6, 7 hard disks available. So you will combine, you will club this physical hard disk into one LAN. Let us say it is LAN 1, LAN 2, LAN 3. So these two hard disks are making LAN 2 and these two hard disks are making LAN 3 here. So you will share the LANs with the ESXi host. Okay, so you can share one LAN with multiple ESXi hosts or separate LAN with multiple ESXi hosts. But in our case, to perform the advanced features, we need to share one LAN with multiple ESXi hosts. Let us say it is LAN 1 and it should be shared with both the ESXi hosts. So SAN is a network of storage devices that can be accessed by multiple ESXi hosts. So this SAN is accessed by multiple ESXi hosts and each ESXi host on the network can access hard drive from SAN as they were local disk connected directly to the computer. So they will access. So these LANs, they will be shared with this ESXi host. Okay, like they are directly connected as hard disk. Okay, so this ESXi host will consider these LANs as the local hard disk. So in this diagram, if you see here, we have SAN storage system that consists of several hard disks, and we can create a LAN combining multiple hard disks. So you will combine multiple physical hard disks and you will create the LANs, and you will share this LAN with the ESXi host or other servers. What is LAN here? LANs are shared raw blocks. That is, LANs are not formatted when they are shared. So these LANs are not formatted. We need to format it after we share this LAN with the ESXi host. Is it clear, guys? Any doubt?
Sir, in which format we will format? GPT or MBR?
No, not GPT, not MBR. It is having a separate format. Okay. So I'm forgetting the name. Okay. You have asked that format suddenly. Just let me remind the name. Recollect the name. What is the name? Okay, no problem. I will let you know whenever I remember. Whenever I remember the name.
No issue.
Okay. So we'll see. Okay, we will see and we'll format in that format only. We'll format the hard disk in that. Okay, no issues. So LANs are shared as raw blocks. LANs are not formatted. When they are shared, we need to format them. So what is LAN here? LAN is a logical unit number, or it is a collection of hard disks. So if you see here, we have multiple hard disks here and we have combined all the hard disks and we form one LAN here. And this LAN will be shared with the server or ESXi host, and which is presented to ESXi host or servers. hard disks in the LANs are physically separated. Okay, in this LAN they are physically separated, but they act as a single hard disk when shared with the server. So they will act as one hard disk when they are shared with the multiple ESXi host. Now guys, we have understood what is SAN, and we have three SAN types. The first SAN type is iSCSI SAN. The second SAN type is FC SAN, and the third SAN type is FCOE SAN. In iSCSI SAN, the medium is Ethernet. Ethernet cable, you can say. If you see in this example, we have SAN, and this SAN is connected with switch. Switch is connected with the ESXi host. So here the cable we are using is Ethernet cable or UTP cable from SAN to the switch to the ESXi host, and this SAN is called as iSCSI SAN. Then we have FC SAN. FC SAN, the medium is fiber optic cable. So with FC SAN, what we are doing, we are connecting the fiber optic cable from SAN to the switch, from switch to ESXi host. The entire medium is fiber optic. Okay, so these types are depends on the cable we are using. If you are using Ethernet cable, it will become iSCSI SAN. If you are using fiber optic cable, it will become FC SAN. Then we have FCOE SAN. What is FCOE SAN? It is a combination of Ethernet and fiber optic cable. Okay, from here to here, from SAN to the switch, you will use the fiber optic cable. From switch to ESXi host, you will use the UTP cable. So it is a combination of fiber optic and UTP cable, and it is called as FCOE SAN. iSCSI stands for Internet Small Computer System Interface. FC stands for Fiber Channel. FCOE stands for Fiber Channel over Ethernet. Okay, so we'll discuss about these different SAN types one by one. So let us discuss about iSCSI SAN. With iSCSI SAN, the entire medium of connectivity, medium in the sense cable, okay, so entire medium of connectivity is Ethernet, and it uses iSCSI transport protocol. So guys, the entire medium is, if the entire medium is Ethernet, it will use a protocol. So, okay, a special protocol for iSCSI. That is protocol is named as iSCSI transport protocol, because the medium of connectivity is entirely ether channel. So if the medium of connectivity is Ethernet, it will use iSCSI transport protocol. Remember this point. And iSCSI, as we have discussed, it stands for Internet Small Computer System Interface. So from here to here and here to here, everything will be the UTP cable or Ethernet cable, and it will use iSCSI transport protocol. So basically iSCSI iSCSI is a SCSI transport protocol, and I stands for internet here. So why this protocol has internet in it? So let us try to understand why it is having internet, because the internet works on TCP/IP protocol. Ethernet also works on TCP/IP protocol. That is why iSCSI is a SCSI transport protocol that provides access to storage device over TCP/IP network. This is our TCP/IP network. Okay, and it will use the iSCSI protocol to transfer the data from SAN to your ESXi host. So guys, iSCSI SAN has multiple components like storage system, disk library, hard disks, LANs, storage processor, Ethernet switch, Ethernet. Guys, the format is VMFS. You were asking about the format, right? Who was asking about the format? Rajiv?
Asking about the format.
Yeah. The format is VMFS. Okay, we have formatted the ESXi host in VMFS format. Remember
VMFS.
VMFS. Okay. So it is having multiple components: storage system, disk library, hard disk, LANs, and storage processor, Ethernet switch, Ethernet cable, and HBA. We will discuss about these components one by one. Let us see the storage system. Okay, guys. So this is the storage system. The complete. It is the SAN here, and this storage system has disk library. Okay, like this. This disk library will have multiple disks. Okay, so you will install the multiple disks on this disk library. Okay, and it is having SP as well. Okay, if you see, this is the storage system. It is having the disk library and it is having SP. So we'll discuss about SP later. Let us see what is this disk library. So disk library has multiple physical hard disks. Then we'll discuss about the storage processor, SP. Okay, which is the part of SAN here. So storage processor is used to perform all the tasks at storage system like creating LANs, assigning the LANs. So where you are creating the LANs and from where you are assigning the LANs? From this SP, storage processor, and this is the picture of SP, which is connected with the disk library. Okay, so this SP is connected with the disk library. From this SP, we will create the LANs and we will assign the LANs to the ESXi host. And it has two SPs here. If you see here, it is having SPA and SPB. Why two SPs? For high availability. You can see here SP1 and SP2. If one SP is not working, the SAN will communicate with the ESXi host from the SP2. It is for the redundancy. So it has two SPs for high availability, which are connected to IP network via Ethernet cable and switch. So this SP, these SPs are connected with the Ethernet switch because we are discussing about the iSCSI SAN. So in iSCSI SAN we use Ethernet cable and Ethernet switch as well. Okay, so it is connected with Ethernet switch via Ethernet cable. Let us discuss about what is Ethernet switch and Ethernet cable. So we are discussing about the iSCSI SAN. Okay, it is an iSCSI SAN. So the medium of connectivity is Ethernet. Okay, the medium of connectivity, this is the Ethernet cable here. So we use this Ethernet cable from SP or SAN to your switch to your ESXi host, and you will use Ethernet switch and Ethernet cable here. So you will use this cable and this Ethernet switch. Okay, this switch will be installed here, and this SPs will be connected with this switch using this cable. And from this switch, you will connect the ESXi host again using this cable. The entire medium of connectivity is the Ethernet here. Then we have one more component called HBA. If you see, this ESXi host is having this component HBA. This is the HBA. Okay, which will be connected on the ESXi host. So HBA guys. Okay, it is HBA, host bus adapter. So what is the use of HBA here? It is an adapter that has functionality to deal with storage. So this adapter is having the functionality or capabilities to detect the storage and to receive the data from storage. Okay, so it will let the ESXi host discover the iSCSI storage. So with the help of this adapter, the ESXi host will discover the host. If this adapter is not available, you can't discover the host. You can't discover the SAN. You can't discover the storage, you can say. Okay, and it is also referred as initiator. This HBA, which is connected with the ESXi host, it is referred as the initiator. You can see iSCSI initiator, and your storage is referred as target, iSCSI target. We'll discuss more about this initiator and target in our coming slides. Till here it is clear, guys. Any doubt?
No, sir, it's okay. It's okay, sir.
Ahmad, Preet, any doubt?
No, sir.
All right. Now let us discuss about the iSCSI SAN terminologies. So it is having some terminologies like iSCSI initiator, iSCSI target. Under this iSCSI initiator, we have hardware initiator and software initiator. We'll discuss about these initiators and target. iSCSI initiator, the physical server or ESXi host can't access the SAN. Okay, this ESXi host, they don't have the ability to access the SAN. Okay, or iSCSI LAN, they can't access the LAN as well because they don't have the capability to do so. To access the iSCSI SAN or LAN, servers need a special component called iSCSI initiator. So they need this iSCSI initiator. In our case, HBA is our iSCSI initiator. This is the hardware initiator. So this initiator will discover the SAN here. It will discover the LANs and it will communicate with the storage. If you don't have the initiator, this ESXi host will not discover the SANs here. It will not discover the storage, you can say. So there are two types of initiators: hardware iSCSI initiator and software iSCSI initiator. Let us discuss about the hardware iSCSI initiator. The hardware iSCSI initiator is our HBA. Okay, this device is our hardware iSCSI initiator, and it is responsible to discover the storage. Okay, which is an adapter. It is like a NIC. Okay, you can see it is having this RJ45 port, and you will connect the cable here. It is like a NIC, but it has the functionality to deal with storage. Normal NICs, they don't have any functionality to discover the storage, to deal with storage. This adapter HBA has the capability or functionality to deal with storage. It will discover the iSCSI storage and it will pass the storage traffic. This is the HBA here on the ESXi host. Let us say you don't have the hardware iSCSI initiator, you don't have HBA. So what will you do? In this case, you will use the software iSCSI initiator. What is this software iSCSI initiator? It is a service that is called an iSCSI initiator service, and if the hardware iSCSI is not available, we can use the software iSCSI initiator. So how will you use? Okay, you will embed the software iSCSI in the NIC card. Okay, so you can use the normal NIC. This is a normal NIC. It doesn't have the ability or it doesn't have any functionality to detect the storage. So what will you do? you will embed the software iSCSI initiator to this NIC, and this NIC will detect the storage now. So this is a software iSCSI initiator, and in our lab we are going to use the software iSCSI initiator only. Okay, the functionality is same. It is to detect the storage and pass the traffic between storage and ESXi host. Now guys, we have access control. Okay, in iSCSI SAN we have a mechanism called access control. What is the use of this access control? It is a mechanism to share the LUNs with a specific server. So guys, let us say we have 3 LUNs. LUN 1, here we have 3 LUNs, LUN 1, LUN 2 and LUN 3. And you want to share this LUN 1 with ESXi 1. So how will you share this LUN 1 with this specific ESXi host? You will use access control. Okay, you will do the configuration in access control and you will share this LUN 1 with ESXi 1. It will not be shared with ESXi 2. Okay, if you want to share the same LUN with both the ESXi host, again you will use the access control. So it is a mechanism to share the LUNs with specific servers. Example, LUN 1 should be shared with ESXi 1, LUN 2 should be shared with ESXi 2. This mechanism in iSCSI SAN is called as access rights. So access control is referred as access rights. Okay. So guys, this initiator and the target. Okay, target is our SAN here. Initiators and targets are identified by different addressing mechanisms. So guys, let us say we want to share the LUN 1 with ESXi 1. How will you share the LUN 1 with ESXi 1? You should know the IP address, correct? You should know the IP address of this ESXi host, then only you will share this LUN with ESXi 1, otherwise you can't share it. Without IP address, can we share the LUN?
No.
We can't share it, right? So there are different ways to identify the ESXi host and targets here, like IP address. Okay, initiators and targets are identified by different addressing mechanism. So first we will see how will you identify the target. Okay, how will you identify the target? So target can be identified in 3 ways. The first way is you will use the IP address. You will assign the IP address, and using the IP address you will identify it. And the second way is it is having IQN. IQN stands for iSCSI qualified name. Like PCs are having IP address, MAC addresses. The same way in storage we have some other identifying mechanism like IQN, EUI. EUI stands for extended unique identifier. So you need to note one thing here: IP address is not used frequently. Okay, we don't use IP address much to identify the target here. We use IQN, EUI only. In real times, you will not use the IP address. So let us see what is this IQN. IQN in iSCSI SAN, targets can be identified. Okay, the targets can be identified by unique addressing format called IQN. IQN stands for iSCSI qualified name. So any address has a format. Like if you write the IP address, it is having 4 portions, like 192.168.1.1. So it is having 4 portions. Each portion is separated by dot. Okay, so any addressing format is having the format the same way. IQN is also having the format. It starts with IQN, then you will have the year, month, then company, then iSCSI alias. This company, okay, in the place of company, you will see the reverse name of your domain. Like if the domain name is vSphere.local, you will see here local.vSphere. This is the format of IQN. Let us see what is EUI. So there is another format to identify the target. We can identify the target using EUI as well. So it is a 16 characters and it is a 64-bit address. Okay, you can see this is the EUI. So with the help of this EUI also you can identify the target. And initiators can be identified in 5 ways. These initiators, they can be identified in 5 ways. Like they can be identified using IQN, EUI, and they can be identified with IP address, hostname ESXi1. You can use the hostname and you can use the MAC address. Okay, the most commonly used methods are IQN, EUI. So, however, it all depends on SAN. What type of initiator addressing will it accept? Certain accept all, certain accept few. Most of the SAN accept only IQN, EUI. Okay, in iSCSI SAN, to provide the security to the LAN, CHAP can be used, which is optional. So guys, in iSCSI LAN, we use CHAP. So you might have heard what is CHAP in CC. So in our last class, we have started storage. So what is storage? It is a device that saves digital data for future use. So we have direct attached storage and shared storage. This shared storage are external storage. They are not directly attached to the computers. So these are the examples of direct attached storage. And we have shared storage. Why do we need shared storage? Anyone?
Shared use storage, sir, so that we can access from anywhere.
We can access the shared store anywhere, but why do we need shared storage in our labs?
So
For
that we can
in
move,
Excel.
so we can move the data from one to another.
Pardon?
To move data from one to another.
Yeah, to move the data from one place to another place. Okay. So we need, this is very important point. We need the shared storage for advanced features like vMotion, DRS, and FT. Why do we need shared storage?
For the vMotion, DRS, and FTT
Okay,
features.
for performing the advanced features of ESXi or vSphere. Got the point?
Yes, sir.
Okay. So, and we need to note one thing here. Shared storage is the external storage. Okay, it is not directly connected. So here, if you see, we have 3 data stores, 1, 2, 3, and all of them are shared with this ESXi 1, 2, and 3. And there are 2 types of shared storage, SAN and NAS. So first we'll discuss about the SAN. Okay, SAN is a network storage that can be accessed by multiple ESXi hosts or servers. So this is the SAN here, and it is accessed by the multiple ESXi hosts. Okay, so it is having some components. We have discussed about the components. And we have 3 different types of SANs. We have iSCSI SAN, FC SAN, and FCOE SAN. So iSCSI SAN, we have the Ethernet medium. Complete medium is the Ethernet medium here, and FC SAN, the complete medium is fiber optic, and FCOE SAN, it is a combination of Ethernet and fiber optic cable. And we have discussed about the iSCSI SAN. So guys, what is this iSCSI SAN?
The iSCSI SAN is accessed by the Ethernet cable.
Okay, so we are using the medium entirely Ethernet here, correct?
Yes.
So in this, the entire medium of connectivity is Ethernet, and it uses the iSCSI protocol. And it is having some components like storage, storage system, disk library, hard disk LAN, storage processor, Ethernet switch, Ethernet cable, and HBA. We have discussed about the different components. of iSCSI SAN. Okay, and it is having in terminology. We have some terminologies: initiator and target. What is the initiator here? HBA. Okay, HBA, it is initiating the request on the behalf of ESXi host. So actually the initiator is HBA. Okay, so HBA is initiating the request on the behalf of ESXi. So who is the initiator here? ESXi. And who is the target here? SAN.
Is the
Okay,
SAN.
ESXi host is your initiator and SAN is your target. Okay, it will initiate the request and SAN will provide the hard disk or LUN to the ESXi host. Remember the terminologies. Okay, so we have hardware initiator and software initiator. HB is the hardware initiator, and if the hardware initiator is not available, you can embed the software initiator on the NIC card. Then we have the access control mechanism. So target will use IP address, IQN and EUI, and the initiator will use IQN, EUI, IP address, hostname and MAC addresses. Okay, now guys, how many types of SAN we have?
SAN we have 3 types.
Three types.
Four.
What are
3 types.
SAN types?
3 types.
3 types. What is the first type?
Sir, iSCSI, FC,
ISC, iSCSI. Then the second type is FC,
FC,
and the third type is
FOCI, FOCI,
FCOE. Okay,
FCI.
FCOE. So we have already discussed iSCSI SAN. Let us discuss about the FC SAN. So FC SAN, in this entire medium of connectivity is fiber channel. So you will use the fiber channel, fiber cables you will use the fiber switch. The entire medium of connectivity is your fiber channel. And if you see, the core picture is same as iSCSI SAN. Okay, it is having SAN here and it is having the switches. Switches are connected with ESXi host. The topology is same here, but the medium is changed. Okay, so the cable will be changed, switch will be changed, and the protocol will be changed. Here we are using the fiber optic cables, right? So which medium we are using here? Fiber channel medium. So if the medium is changed, the cable will be changed and the switch will be changed and the protocol will be changed. It uses the fiber optic cable. Okay. So fiber channel protocol, just 1 second. All right. Just give me 1 minute, guys. So we are dealing with storage. We have 2 types of storage, DAS and shared storage. DAS means you will connect the storage directly to the computer like hard disk. And shared storage means you will share this will be the external storage. Okay, it will not be connected directly to the server. It will not be connected to the ESXi host, and we need this shared storage to perform the advanced feature like fault tolerance, vMotion, etc. So in this shared storage, we have SAN and we have NAS. Under this SAN, we have again 3 types: iSCSI SAN, FC SAN, and FCOE SAN. So we have already covered iSCSI SAN, FC SAN and FCOE SAN, and we'll discuss about NAS. Okay, so the second type of shared storage is NAS here. So let's start NAS here. NAS stands for Network Attached Storage. It stores and shares the data for multiple ESXi hosts or computers that can be accessed remotely. So you have NAS here. Again, you can share the data with multiple ESXi hosts. Okay, similar to SAN. In SAN also what we do, we share the data or we share the LUNs with multiple ESXi hosts. It is also a storage system. It also contains multiple disks. So if you see, this is the NAS here, and it is having multiple hard disks which can be shared with multiple ESXi hosts. With NAS, we are not sharing LUNs here. Unlike SAN. In SAN, what we do, you have multiple hard disks and you will create the LUN from this hard disk. Okay. Whereas with NAS, you are not going to share any LUN here. So if you are not sharing LUN, then what will you share? We share the folders in NAS and we use the file sharing protocol to share the folder. So guys, what you will do in NAS, you will create the folder and you will share this folder with ESXi host. Okay, like we create the folders in our computers. We create the folders in our computers and we share this folder. The same way you are going to create the folders in NAS and you will share the folder with multiple ESXi hosts, and we are using file sharing protocol to share the folders. Let us see the NAS components. NAS is having multiple components like enclosure. You see this box. It is referred as enclosure. Inside this enclosure, you will have processor, you will have fan, okay, and you will have power supply, and you will have motherboard, RAM, and it will have the NAS storage. You will see the hard disks here. Okay, you will install the hard disks. If you see these slots are for hard disks, and it will have the operating system as well, and it will have NIC card. If you see, it is having this NIC card, and we are going to use the UTP cable. Okay, you will using the UTP cable. You will connect this SAN to the switch, and switch will be connected with the ESXi host. So it will use the UTP cable and it will use the normal switch as well. These are the components of NAS, and there are NAS protocols. Okay, there are multiple NAS protocols like CIFS, SMB, NFS. CIFS stands for Common Internet File System Protocol. SMB stands for Server Message Block, and NFS stands for Network File System. So ESXi supports NFS protocol for sharing the data. It doesn't support the other two protocols. Okay, it is having some other protocols as well. It supports only NFS, ESXi. Okay, and what this NFS protocol will do in vSphere environment is it allows ESXi host to access the files over a network in the same way they would access the local storage files. So it will allow the ESXi host to get the files from NAS, okay, as though it is getting the storage from the local device. Let us see the NAS terminologies. So folders are referred as NFS volume. As we have discussed, we don't share the LUNs here. In NAS, we create the folder and we share the folders. These folders are referred as NFS volume. And sharing, okay, we share the folder. That sharing is referred as exports, which means we export the NFS folder, or we share the folder means we export the NFS volume. And you need to note here, no special addressing, no special medium required. Okay, it will work with the Ethernet cable and NIC. Here we don't need anything special. Okay, it is like you are using the normal computer, normal server or normal PC. You will connect the UTP cable and you will connect that UTP cable. Okay, you will use the UTP cable here and you will connect this the other end to the Ethernet switch. And here we will connect the ESXi host to the same switch. Okay, and servers and NAS are identified by IP address and host name. Okay, so there is no special addressing here. They will be identified by IP address and host name like normal computer. And let us say the storage admin task. So guys, this NAS is managed by storage admin, and this ESXi host is managed by vSphere admin. Okay, so let us see the responsibilities of storage admin first, then we'll see the responsibilities of vSphere admin. So this storage admin, he will create a folder and share it with the ESXi host. So storage admin is responsible for creating the folder and he will share the folder with ESXi host. The access control mechanism in NFS share. Okay, it is this access control mechanism is known as NFS share, and the storage administrator is going to mention the list of servers who would be able to access the particular NFS volume. So what it will do, he will create the folder and he will contact you. Okay, you will provide the IP address. Let us say the IP address of this ESXi host is 192.168.1.10 here. So you will provide the IP address to the storage administrator, and storage administrator will share the folder with this IP address. It will add the IP address in that folder. So that folder will be exposed to this ESXi host. Okay, if you want to share the same folder with multiple ESXi hosts, so you will provide multiple ESXi IP addresses. Let us say 1.10 and 1.20. So he will create one folder and he will add 1.1 and 1.20, and the same folder will be shared with the ESXi1 and ESXi2. So the storage administrator is going to mention the list of servers who would be able to access the particular NFS volume. NFS volume in the sense the NFS or the folder. Then let us see the vSphere administrator tasks. Okay, vSphere administrator means we are the vSphere administrator, and let us see what we are going to do. So when the vSphere admins access the NAS, okay, whenever we are accessing the NAS, they need to provide the IP address of the NAS device. So whenever we are accessing the NAS, we need to provide the IP address. So you will get the IP address of NAS from NAS admin. You will contact the NAS admin, then you will access the NAS using that IP address. Let us say the IP address of NAS is like 192.168.1.200. Okay, so NAS or storage admin will provide this IP address to us, and we will access this NAS using this IP address, and they will get the IP address from NAS admin. Then the shared path is given by the storage admin of the volume. So he will create the folder and he will provide the shared, he will provide the path as well. Okay, so you can use that path and you can access the file here. Then you are going to mention the shared path of particular volume. So you will mention that path here on ESXi host, then volume gets mounted on ESXi. So as soon as you provide the path of this shared volume, your volume gets mounted here as data store. So here we are not going to format anything. Okay, there is no formatting here because in NAS you are not accessing the SCSI block. Okay, you are not accessing any LUN here. You are not accessing the device. You are accessing just a space. Okay, you are accessing the folder. So you will not format the folder. Okay, so which is being shared with file sharing protocol. So this folder is being shared here and we don't format the folders, guys. Okay, we will get this space and we will mount that space on ESXi host. So directly shared folder getting mounted as your data store. So you will get the shared folder and it will be mounted on ESXi host as data store 1, data store 2, etc. Clear, guys? Any doubt till here?
No, sir.
Others?
No.
Yes, sir.
Okay. Rengal, Rajiv.
No doubt, sir.
Good, sir.
All right. Let us move forward. So, guys, the drive is under the control of NAS operating system. So, this drive, whatever the drives are there, they are under the control of NAS operating system. Okay, it required a special operating system. So that operating system could be Windows, Linux, or a special operating system provided by the manufacturer. So this NAS required the operating system. It can be Windows, it can be Linux, or it can be a special operating system from the developer of this NAS. By default, okay, let us see the root permission. There is a concept, or you can say this NAS has root permission. Okay, so if you want, if ESXi host need the NFS folder, it required the root permission. Okay, so NAS administrator or storage administrator will create the folder and he will provide the root permission to that folder, then only the ESXi host can access it. If the root permission is not there on that folder, ESXi host can't access that folder. Okay, so by default, root, just guys, just give me 2 minutes, then we'll continue. Alright, so this folder required the root permission. Okay, without root permission, ESXi host can't access therefore, and by default, this root permission access is denied. Okay, so you need to have the permission here. It will work with Linux and Unix operating system even with a denied permission. Okay, if you are using Linux operating system, if you need the folder for Linux operating system, Unix operating system, they will access the folder even without the denied permission. But ESXi required the permission. Okay, because this Linux and Unix, okay, they work on NFS only. So with the denied permission also they will access it. Okay, but ESXi required root access so that particular folder can be accessed by ESXi host. Okay, and this requirement your store admin would be aware of. So guys, this root permission condition, it should be known to this storage admin. Okay, and he is responsible to provide the root permission. Okay, if he is unaware of this condition, you should inform him. Okay, if you are unable to access the folder in your ESXi host, okay, so you should inform the storage administrator to provide the root permission. Okay, so if he doesn't know, you have to inform your admin. And what will you do? There is one terminology for granting the root access. We call it no root squash. So whenever the NFS volume is exported, you have to go and you need to configure this command no root squash option. What does it mean? No root squash option granting the root access is called no root squash. So you should not be scared of these terminologies. Whenever you heard this terminology, no root squash, so you should understand that he is talking about the root permission here. And guys, ESXi supports ESXi NAS, also supports multipathing. Okay, so but you need to make sure that port binding is configured on the physical switch. Okay, so it also supports the multipathing. Okay, but let us say this is a switch here. On this switch, you should configure the port binding. Otherwise, the multipathing is not going to work. So ESXi supports NAS multipathing, and port binding must be configured on the physical switch for NAS multipathing or NFS multipathing. Without this, NFS multipathing will not work. So it was about NAS. Any doubt in NAS?
Sir, how we will do port binding?
Port binding means you need to contact the network administrator who will manage the switch.
Okay.
Network administrator, right? So you need to contact the network administrator. He will bind. He will do the port binding. And in CCNA, it is there. Okay, we have I think covered the port binding in CCNA. All right, guys. Any doubt?
No, sir.
No, sir.
Preet Ringal, any doubt?
No.
Ringal?
No, sir.
All
No,
right.
sir. No, sir.
Now, guys, we have discussed about the SAN and NAS, and we are going to do the lab. So, right now, our current scenario, our current topology is like this. We have ESXi1, and ESXi2. We have created some virtual machines on both the ESXi host. On ESXi2 we have vCenter server as well. And these virtual machines, they are saved on the local storage. Okay, they are shared on the local, or you can say they are saved on DAS. Okay, now our requirement is to perform the advanced concepts like vMotion, fault tolerance, DRS, etc. For that we need the external storage, we need the SAN. Let us say we need SAN. Okay, SAN will have the shared storage. So you will create the LUNs. Let us say you have created LUN1 on SAN and you will share the LUN1 with ESXi1 and ESXi2. Same LUN, same storage will be shared with ESXi1 and ESXi2. Okay, so in real network you will have the disk library, you will have the switches, cables, etc. But in our lab, what you will do, we are going to use, okay, we will create one virtual SAN with the help of Windows Server operating system. So what you will do for our lab, you will create one virtual server. Okay, after creating the virtual server, you will install the Windows 2012 operating system and you will install the SAN services. Okay, you will install the SAN services. On this Windows machine, you will create the LUNs and you will share the LUNs with ESXi1 and ESXi2. This will be in our lab. Okay, in our lab, we will use the Windows Server operating system machine as SAN. Clear guys? Clear the concept? Or any doubt?
No, sir.
So first what we will do, we will create the virtual server, then we'll install the Windows Server 2012 operating system. After that, we will see how to make this machine as SAN. Okay. So let us create the virtual server first. So we will install the Windows Server operating system. We will install Windows Server 2012. And where do we want to save it? We'll save it in C. Under C we have 5 PM vSphere batch. Under this we'll create one more folder for SAN. So let us give 200 GB and we'll click next. So this is the size of hard disk. We'll click next, then finish. Then we'll provide the ISO path of Windows Server 2012. So you guys are getting what we are doing, right? Already confusion. Anyone
No,
what
sir.
we are doing here?
We are installing Windows Server 2012
Why?
for creating the virtual NAS, SAN.
Very good. So for creating the SAN, we are installing the Windows Server operating system. So we'll power it on and it will install the Windows Server operating system now. Windows Server 2012 operating system. Then we'll see how to make this machine as a SAN. So we are going to see the iSCSI SAN. Okay, then we'll click next. We'll click install now. We'll accept the terms. Then we'll click new. Okay, we are getting 200 GB hard disk here. Apply. And we'll click next. And it is installing the operating system. It will take few minutes. We'll wait for the installation to be done. So we have installed the operating system. So administrator account is created. We need to assign the password. We'll click finish. So the password is not matching here. Let us check the password. Here it is in O is in capital letter. Okay, that is why it is not matching. Then we'll click finish. Okay, so we need to press Control Alt Del to sign in. You will click this option here. Then you will provide the password. Okay, so we have logged in this Windows Server 2012 successfully, and we'll set up the icons on the desktop. We'll wait for a few seconds. We'll let the server settle down. Okay, how to set up the icons? Anyone? We'll go to control panel and we'll search icon. Then we'll go to show and hide common icons on desktop. Then you will select the icons. Okay, so icons are set now. Guys, we have not started anything related to SAN. Okay, we are just setting up the server. So operating system is installed. We have set up the icons on desktop. Now we need to install the VMware tools. What is this VMware tool? It is nothing but the drivers of this server. Again, it is not related to the SAN. So how will you install the VMware tool? You will go to VM, then you will select this option, install VMware tools. After selecting this option, you will select this PC, then you will double click here, DVD, and it will start installing the VMware tools. After installing the VMware tools, it will get restarted. If you see the screen, it is not full. After installing the tools, you will get the full screen and it will install the other drivers as well. You can see it is installing the drivers. Then we'll click finish. We need to restart the server. So after restarting the server, we'll install the service, SAN service. Okay, iSCSI service you can say. which will help us to make this server SAN. But in real network, you are not going to use this method. It is for the lab only.
In real scenario, there will be the hard disk miss.
Yeah, complete setup is
Server.
there, which we have discussed.
Okay. So after completing this training, you will provide any certificate also?
Yes, yes, you will get the certificate. Okay, so just drop one message in the group after completion of this course. You will get the certificate.
Okay. Sir, earlier I have done the MCSC also. I haven't got the certificate. Can you provide?
Check with the management. Okay, they will provide you. Okay, you will get everything from there.
Okay.
If there is an issue, just let me know. I will talk to them. Okay.
Okay, sir.
So here Windows Server 2012 is ready. Now we need to install the service. Which service? Let me show you. So you will install the iSCSI service. So you will select this first option. Okay, let me close it and let me show you from scratch how we'll install the service. You will go to Server Manager. You will open the Server Manager to install the service. Okay. Add roles and features. Then you will click Next. 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 Here you will select the file and storage services. You need to expand it. Then you will get this option, file and iSCSI services. Again, you need to expand it. Under this file and iSCSI services, you will select these two options. iSCSI target server, then you will add features. Then iSCSI target storage provider. Then we'll click these two services make this server SAN. Then we'll click next, next, and we'll click install. Okay, so installation succeeded. We'll close it. Okay, guys, and after installing the operating system, it has taken the IP address automatically. Okay, so let me show you the IP address before moving forward. We need to configure the IP address as well. So it will take the IP address from the same network. That is why it is working. Okay, so IP config. The IP address is 140.120. Let us change the IP address. Let us configure the static IP address. One 192.168.140. Let us say it is 110. 192.168.140.2. DNS is also 192.168.140. Then we'll click OK. It is closed now. So guys, we have installed the service. So after installing the service, we need to create the LUN on SAN or not?
Yes, sir.
We will create LUN1 and we will share this LUN1, the same LUN with ESXi1 and ESXi2. Correct?
Yes, sir.
So to share this LUN with ESXi1 and ESXi2, we need the IQN number or not? We need the IQN
Yes.
number of ESXi1 or and ESXi2 or not?
Yes, sir.
Yes, sir.
So we need to get the IQN number first from these two ESXi hosts. Okay. So remember one thing, we are creating the LUN1 and this LUN will be shared with ESXi1 and ESXi2. So to share the same LUN with ESXi1 and ESXi2, we need the IQN number from both the servers. So let us see how to get the IQN number. So we need to access the vCenter server. So vCenter server IP address is 192.168.140.100.
100.
Launch vSphere client. So administrator@vsphere.local. This is the account we have created on vCenter server. So guys, how to get the IQN number? Let us try to understand. So we need to get the IQN number of both the hosts. So first we'll go to ESXi1. Under this ESXi1, we will go to configure. Under configure, we will go to, just 1 second. Okay, we'll go to the storage adapter. Do you see any IQN number here? Do you see? No, right?
No.
Because we don't have any HBA here. So we need to add the software adapter. Remember the point? We can install the software initiator as well.
Yes.
Okay, so you will select this option, add software adapter. Okay, you can add the SCSI or FCOE adapter. We'll go with add software iSCSI adapter. So once you add the software initiator, you will get the IQN number. We'll click OK. Now you can see software adapter is added and you will see the IQN number. Okay. So how to get the IQN number? Either you can write it or you can copy and paste from here. Let us copy the IQN number. It is the ESXi1 IQN number. Let us open the notepad and we'll paste this IQN number here. And we need the IQN number of ESXi2 or not. We want to share the same LAN with two
Yes.
ESXi. So we need to go
Yes.
to 140.20. Under 140.20, again you will go to configure. Under configure, you will go to storage. Under storage, you will go to storage adapter, and you will select this add software option. Again, we will go with iSCSI adapter, software iSCSI adapter. So IQ number is appearing here. So you will copy the IQ number here. We'll copy it and we'll paste it here. Now guys, we have got the IQN numbers. And as we have discussed, we are using the local data stores, correct? If you see here, this ESXi2 is having data store 1. If you go to ESXi1, the local data store name is data store 1. It doesn't have any LUN here. Okay. So after adding the LUN, you will see LUN 1. So let us go to the SAN. Okay, here under the server manager, you will go to the file and storage services and you will see this iSCSI option. Under this iSCSI option, you will select this option to create an iSCSI virtual disk, start new iSCSI. So you need to click this option. After clicking this option, we will select volume. So we have 200 GB hard disk on this server. Okay, so we'll select C, then we'll click next. We need to provide the name. So let us give name as LUN1. Then we'll click next. And what should be the size of this LUN1? So let us give 95 GB. Okay, so dynamic expansion means whenever it required, it will provide you the hard disk. We are doing the lab, so let us go with dynamic expanding. You can go with fixed size. If you select fixed size means you will get the 90 GB right away. So let us go with dynamic expanding. Then we'll click next. Okay, now we need to provide the target IP address. So in real, here we will provide the IP address. Okay, new iSCSI target. We'll provide the IP address of this SAN server. What is the target SAN, correct? What is the target?
It's the sun.
SAN. Initiator? Who is in ESXi host? So in the in this option, in target option, you will assign you will provide the IP address of this current server. You will click next. Okay. And what is the IP address of this current server? 192.
140.1110.
140.1110. Then we'll click next. Okay. Then we need to add the access servers. We need to add the initiators here. Okay. We'll select add and we'll select the second option. Enter a value for the second type. IQ number we need to provide. So we have already taken the IQ number. So ESXi1 IQ number. We'll copy and paste it here. We'll click OK. And we'll add one more IQN number. Okay, because we are sharing the same LUN with two ESXi host. ESXi2 IQN number. We'll add it. Okay, so two IQN numbers are added. If you want to share this LUN with ESXi3, then you need to have the IQN number of ESXi3 as well. Then we'll click next, and we can, as we have discussed, we can configure the chat. Okay, so we don't want to configure the chat. If you want to configure, you need to provide the username and password. Okay, so we'll click next. and you can review the settings here. Okay, and if you want to change, you can go back and you can change the settings. Then you will select this create option. So guys, it is creating the virtual disk. It will create the target. It will set the target access. Everything is completed, which means the LUNs are created. Now we need to attach the LUNs to ESXi1 and ESXi2. From here, we have done our process. The SAN steps are completed. The SAN part is done here, and we need to go to ESXi1 and ESXi2, and we will add the LUN there. So let us go to the vCenter server, and if you see, it is having only one data store, that is the local data store. So if you try to add the data store here, you can't add it. You will go to storage, new data store. Okay, so we are configuring VMFS. We'll click next. Here you should see the LUN. Okay, it is LUN is not appearing here, so we can't add the data store. We can't attach the LUN here. So how to attach the LUN? So first you need to go to this configure option. Okay, you will select the ESXi host, then you will select the configure option. Under this configure option, again you will go to storage adapters. Under this storage adapter, you will select the software iSCSI. Under this software iSCSI option, you will select the dynamic discovery. We need to discover our LUN first. Okay, how will you discover the LUN? You will go to storage adapter, then you will select the logical storage, software storage, then you will select this option, dynamic discovery. Under this dynamic discovery, there is no LUN available. Then you will select add option. Then you need to provide the IP address of the SAN here. What is the IP address of SAN? This is the IP address, correct?
Yes, sir.
Then you will click OK. Then you need to refresh it. You can see the IP address and you need to refresh or rescan the storage. Then rescan the adapter as well. And you will, under the path, you will see the LUN number here. Okay. And you will see Microsoft iSCSI disk option as well. Previously it was empty. After the dynamic discovery, you will see this option here. So it is available. The same thing you will do on ESXi2 as well. You need to discover it dynamically. So again, you will go to configure storage adapter. Then you will select the software adapter, and you can see there is nothing here because it is not discovered yet. The LUN is not discovered yet. So you will select the dynamic discovery option. Under this dynamic discovery option, you will click add. Then you will type the SAN IP address here, which is 192.168.140.110. Then you will click OK. Then you will rescan the adapter. You can rescan the, or it will refresh the storage and it will refresh the adapter. Then you will see the options here. So it has detected the LUN one. Now what we will do, we will go to the storage, or what we can do, you can go to the ESXi1, then you will go to storage, then you will go to action, Under action, you will go to storage and you will select new data store. Okay, currently we have only the local data store. Now you will have the learn one as well. So VMFS, then you will click next here and you will select the hard disk. Previously we were not seeing the hard disk, and you will give the name. Let us name it learn one. Then you will click next. So it is 0% done. Now it has added learn one on ES6i1. Let us add the same learn to ES6i2. Okay, we'll go to ES6i2, then we'll go to data store, then we'll go to actions. Under actions, we'll go to storage, then new data store, VMFS. Okay, if you are configuring the NAS, you will select the second option. Then we'll click next. Okay, it is not appearing. Why it is not appearing? It should be available here as well. Okay, it is already there, guys. So as soon as you have added to 10, it is added to 20 as well. Okay, so learn one is available on both the ESXi hosts. So we have shared the learn. Tomorrow, what we are going to do, we will move the virtual machines from local storage to learn one. Okay, this local storage is having multiple virtual machines. So we will move them from local data storage to learn one on both the ESXi host. Any doubt in today's class?
No, sir.
Others?
Sir, MFS also we will configure.
No, we will see only SAN. Okay.
Okay, sir.
Procedure is the same, huh?
The procedure is same, almost same. If possible, I will try to explain NFS as well. Okay.
Okay, sir. Okay, sir.
Clear, guys?
Okay, sir.
Yes,
Okay.
Ringal, Preet, any doubt?
Yes.
No.
All right, guys. So see you tomorrow. Take care. Please practice this lab. Okay. And I will upload the video and document as well. Okay. Take care.
Thank you.
Welcome.
Thank you.
Welcome. Okay. So we need to create the standard switch from vCenter server. So as we have discussed, whatever we do on ESXi host directly, we can do it via vCenter server as well. So we will create the standard switch here. So how will you create the standard switch via vCenter server? You need to go to the host. You need to select the host. Okay. Then you need to select the configure option. This configure option. Under this configure option, you will go to networking option. Then you will see the standard switches. Okay. You will select the standard switch. Okay. Let us go directly to the vCenter server. Okay. You will go to configure. Under configure, you will go to networking. Under networking, virtual switches are there. Okay. So here, this is 6.7. Okay. And you can select the add networking option here. First, you will go to the ESXi host where you want to create the standard switch. So we have two ESXi hosts. Let us say we want to create the standard switch on 140.10. You will select this option first. Then you will go to configure. Under configure, you will go to virtual switch, virtual switches. Under virtual switches, you will select add networking. So under add networking, you have two options, three options here. VM kernel network adapter, virtual machine port group for standard switch, physical network. So you can select any option. So you can select either VM kernel option or virtual machine port group for standard switch option. Okay, then you will click next. After that, it is asking, okay, why we are creating this port group for the existing standard switch, or you need to apply that port to the new standard switch. So select the new standard switch. Okay, we are creating the new standard switch here. So we will select the second option, then we will click next. Then if you have any physical adapter, you need to select the adapter here. So we don't have any physical adapter. We have added all the physical adapters to the standard switch. Okay, let us, what we do on switch 2, on ESXi2, we have the physical adapters. Okay, so you can see configure virtual switches, add network. We'll select the second option, next, and we want to add this port to the new switch. So you have selected the second option, then we'll click next. Now you can see we can add the ports because this ESXi2 is having 3 NIC cards. So we will select one NIC card. It will be added to the new virtual switch as the uplink. Okay, then you will get the information here. If you want to add one more NIC card, you can add one more NIC card. Okay, it will provide the redundancy. Then you will click next. And what do you want to give the label here? So let us give the label as like VM network via vCenter. Okay, we are creating this switch, we are creating this port via vCenter. So we are adding vCenter here. So you need to provide any meaningful name for our lab. This is the meaningful name. Okay, then we'll click next. Okay, then we'll click next. vSwitch1. So new standard switch name is vSwitch1, and the port name is VM network via VC, and MTU is 500 and it is having 2 NIC cards. We have added 2 NIC cards. Then we'll click finish. And you will see the standard switch here. You can see we have the VM network and we have 2 uplinks. It doesn't have the VM kernel port. So again we need to add the VM kernel port. So how will you add the VM kernel port? You will go to this virtual switches, you will go to the top of this page and you will select this add networking option, and we want to create the VM kernel adapter. Okay, we'll click next, and we are creating this VM kernel adapter for the existing switch. Okay, so we need to select the existing standard switch, we need to browse it, vSwitch1. We want to create this VM kernel adapter for vSwitch1. Then we'll click OK, then we'll click next. And as we have discussed, VM kernel port will accept multiple traffic. So you can select the traffic as well. vMotion, why you are creating this V kernel port? We are creating for vMotion and we are creating for management. Okay, we'll click next, and we are creating this for management means we need to assign the IP address as well. So let us assign the IP address 192.168.140.3. 192.168.140.2. Let us assign 5 here. I think 3 is already there. And we'll click next. Subnet mask. Okay, this is a subnet mask, guys. 255.255.255.0, and default gateway is already selected. We'll click next. Then we'll click finish. If you see here, 192.168.140.5 IP address is assigned, and you can add the virtual machine to this VM network via VC. So we can access the ESXi2 using this IP address as well, 140.5. Let us verify 192.168.140.5. Root NOA123. So this is the second IP address of ESXi2. So I think the password is wrong here. What happened? We are able to access the ESXi2. Okay, you can see this ESXi host is having one virtual machine. That one virtual machine is the vCenter server. All right, guys. Any clear, guys? So yesterday we have created SAN, we have created LAN, and we have shared the LAN 1 and LAN 2 with ESXi1 and ESXi2. And if you see here, so let me open the vCenter server, and if you see, we have logged into vCenter server, and if you go to 140.10 and if you go to data store, we have LAN 1. Okay, and data store is the local storage here, and which is having all the virtual machines, because previously we have created all the virtual machines in local data store. Let me show you. If you see this Windows Server 1, this is our first virtual machine. Okay, it is available in data store 1 in the local data store. And if you go to ESXi2, okay, and if you check the data store, again it is having LAN 1 and local data store. And we have installed the vCenter server in the local data store. Is it clear, guys? Any doubt?
No.
Others?
Yes, sir.
It is clear, right? So now what we will do, we will move this Windows Server 1. Okay, Windows Server 1 is in local data store. Okay, we will move this Windows Server 1 into LAN 1. Okay, so we will go to server 1. So this machine is powered off. Okay, if you observe here, this machine is powered off. And what we will do, we will move, we will right click on this virtual machine and we will select the migrate option. Okay, when you select the migrate option, you will get three options here. Change compute resource only, change storage only. So you will select the second option to move the VM files from one data store to another data store. So what we are doing here, we are moving the files from local data store to LAN 1. So you will select the second option, change storage only. So it will migrate the virtual machines from one storage to another data storage. Clear, guys? Then we'll click next. It will check the compatibility. Okay, so you need to select the destination here. So we are moving the virtual machine files from data store to LAN 1. So we need to select LAN 1. It is checking the compatibility, and compatibility is succeeded here. Okay, compatibility checks succeeded. So we can migrate the files of the virtual machine from data store 1 to LAN. Then we'll click next. Okay, if you want, you can verify the settings here, and you will click finish. Okay, now it has started the migration. So guys, if you observe here, we are moving the data store, okay, while this virtual machine is powered off, correct? Is this virtual machine powered off or powered on?
Power on, power off.
Powered off, right? So migrating the powered off virtual machine from one data store to another data store is called as cold storage migration. It is called as cold migration. Okay. So it is 36% completed. Meantime, let us check what is the meaning of cold migration. So cold migration is the migration of powered off or suspended virtual machines between ESXi host or data store. So guys, what is cold migration here? What is the meaning of cold migration?
Machine which is powered off or suspended can be migrated from one data store to another data.
Beautiful. Very good, Raj. Okay, so we migrate the machines when they are powered off, correct? So let us check whether it is migrated or not. So it will take some time because we have installed Windows Server operating system. So it will take time. Okay, so we'll wait for the migration to be completed. You can refresh the page as well. Okay, so 38% completed, and you will see the Windows Server operating system in LAN 1 now. Previously, it was in data store 1. So after the migration, you will see learn 1. Okay, and you can verify the learn 1 as well. So you will go to the ESXi host and you can see learn 1 doesn't have any virtual machines. Okay, after the migration, you will see the virtual machine here and you will see the virtual machines in data store 1. Okay, so you will select the virtual machine option. So you will see a list of virtual machines in data store 1 and we have Windows Server 1 also, and in learn 1 we don't have any virtual machine. After the migration, you will see the Windows Server 1 in learn 1. So how will you verify? You will go to the ESXi host. If you want to verify the ESXi host data store, you need to select the IP address of the ESXi, then you need to check the data store. If you want to check the virtual machine data store, so you need to select the virtual machine. Okay, then you will select the data store. So you will come to know this virtual machine is the part of data store 1. So 40%, 41% is completed. So guys, everything means it is clear, my voice and video, everything, because
Yes, sir.
I am connected to my data here. Okay, I am using the mobile phone data here because my primary internet connection is down. So hope everything is clear. Okay, thank you guys.
So
Thank you.
Clear, sir.
Sir,
So this cold migration is used when the virtual machine contains complex application setup. So let us say one virtual machine is having complex setup, and if you try to migrate the live virtual machine when the virtual machine is powered on, so when you try to migrate the live virtual machine, you may face some issues. Okay, so better to shut down the virtual machine and migrate it. So you can migrate it, you can do the cold migration very easily. Clear, guys? So it was
Yes,
about
sir.
the cold migration. In this section, we will discuss about vMotion, the migration of live virtual machine from one host to another host is called vMotion. Let us try to understand what is the meaning of this sentence with this example. Let us say we have one physical server, and on the top of this physical server we have installed ESXi. And it will become the ESXi host. Let us say the host name is ESXi1. Then on the top of this ESXi, we will create 3 virtual machines. We have virtual machine 1, virtual machine 2, virtual machine 3. On the top of this virtual machine, we have installed the operating system, server operating system. Then on the top of this server operating system, we have installed the applications. Applications like SQL Server, this is our database server. Then we have installed web server and Active Directory. And these services are accessed by the users. Okay, everything is working fine. After some times, this ESXi1 is running very slow. It is giving some issues. Okay, so to fix these issues, we need to shut down this server. If you shut down this ESXi host, these services will not be available to the users. This is the problem here. Okay, if you have only one ESXi host in your network, and if it is down, all the virtual machines will not be available to the user. So what you will do, you will take one more ESXi host. Okay, you will take one more server. Let us say you have installed ESXi on the top of this server, and let us say it is ESXi2. So this ESXi1 is having some issues. It is running very slow, and we need to fix it. We need to do the maintenance of this ESXi1. To do the maintenance, we need to shut it down. So we will not shut this ESXi1 right away. Before shutting it down, we will migrate the virtual machines of this ESXi1 to ESXi2. And the procedure, the method of migrating the live virtual machines from one ESXi host to another ESXi host is called vMotion. So vMotion is used to migrate the live virtual machines from one ESXi host to another ESXi host without affecting any services. So guys, this is the beauty of virtualization, or this is the beauty of vMotion, where we are migrating the live virtual machine from one server to another server without affecting any services. Servers will be working during the migration. VMware referred this technology as vMotion, but for me it is a vMagic. In this section, we will discuss about vMotion, the migration of live virtual machine from one host to another host is called vMotion. Let us try to understand what is the meaning of this sentence with this example. Let us say we have one physical server, and on the top of this physical server we have installed ESXi. And it will become the ESXi host. Let us say the host name is ESXi1. Then on the top of this ESXi, we will create 3 virtual machines. We have view virtual machine 1, virtual machine 2, virtual machine 3. On the top of this virtual machine, we have installed the operating system, server operating system. Then on the top of this server operating system, we have installed the applications. Applications like SQL Server, this is our database server. Then we have installed web server and Active Directory. And these services are accessed by the users. Okay, everything is working fine. After some times, this ESXi1 is running very slow. It is giving some issues. Okay, so to fix these issues, we need to shut down this server. If you shut down this ESXi host, these services will not be available to the users. This is the problem here. Okay, if you have only one ESXi host in your network, and if it is down, all the virtual machines will not be available to the user. So what you will do, you will take one more ESXi host. Okay, you will take one more server. Let us say you have installed ESXi on the top of this server, and let us say it is ESXi2. So this ESXi1 is having some issues. It is running very slow, and we need to fix it. We need to do the maintenance of this ESXi1. To do the maintenance, we need to shut it down. So we will not shut this ESXi1 right away. Before shutting it down, we will migrate the virtual machines of this ESXi1 to ESXi2. And the procedure, the method of migrating the live virtual machines from one ESXi host to another ESXi host is called vMotion. So vMotion is used to migrate the live virtual machines from one ESXi host to another ESXi host without affecting any services. So guys, this is the beauty of virtualization, or this is the beauty of vMotion, where we are migrating the live virtual machine from one server to another server without affecting any services. Servers will be working during the migration. VMware referred this technology as vMotion, but for me it is a vMagic. So when should we perform this vMotion? Okay, so there must be some reason, right? So it is not like vMotion and you have started migrating the virtual machine. There should be the reason to migrate the virtual machine from one ESXi host to another ESXi host. The first reason is the resources are less in one server and the other server is having the enough resources. So let us say this ESXi host has consumed 90% of resources like RAM, CPU, hard disk, etc. And this ESXi2 is utilizing only 30% of resources. So you will also observe that ESXi2 is consuming only 30% of resources. So what you will do, you will migrate some virtual machines from ESXi1 to another ESXi2. So from one to ESXi2. So when the resources are less, one server and the other server is having the enough resources, you will migrate the virtual machine. You will use the vMotion. And what is the second reason? Let us say ESXi1 is underperforming. It is having some issues. Okay, it is working very slow. And what you need to do, you want to fix it. Okay, so to fix it, you might be restarting this ESXi1. So if you restart the ESXi1, the virtual machines will be down, right? They will not be available to the users. So what you will do before restarting the this ESXi host, or before shutting down the ESXi host, you will migrate the virtual machines from ESXi host to another ESXi host. So when there is some error or hardware issue on ESXi host, you will migrate the virtual machine to the ESXi host, which is working fine. Now guys, let us discuss when you can perform the vMotion. What are the prerequisites for vMotion? So you need to have the vMotion license. So we are doing the trial version. We are using the trial version. So you will get the complete license, including vMotion license. But in real networks, you need to check if it is having the vMotion license or not. Then VM must be stored in the shared storage. Okay, so we have created LUN1. All the virtual machine which you want to migrate should be in this shared storage. And source and destination ESXi must share the same data store. So as you can see, they are sharing the same data store here. In our lab also, they are sharing LUN1. And sufficient resources on the target host. So ESXi2 should have the sufficient resources. It should have the resources to accept the another virtual machine. If it is not having the resources, so there is no, you can't migrate the virtual machine from one ESXi to another ESXi host. So resources must be there. And vMotion must be enabled in the VM kernel port on both the ESXi hosts. So guys, if you remember, VM kernel port is used to accept the vMotion traffic, SAN traffic, NAS traffic. So we need to enable the vMotion on VM kernel port. Okay, you can enable it on the existing VM kernel port, or you can create a separate VM kernel port for vMotion. We will see, okay, how to create the separate VM kernel port and how to enable the vMotion on VM kernel port. This is very important. If it is not enabled, you can't migrate the virtual machine from one ESXi host to another ESXi host. And guys, the CPU family should be same. CPU family in the sense, let us say in ESXi 1, we are using Intel processor. So on ESXi 2 also you should have Intel processor. The family is Intel. If possible, try to have the same model. Okay, if the model is not same, the family should be same. Okay, so CPU family should be same. It is recommended to have the same model, but it is not compulsory. Let us say you have different families, like ESXi1 is having Intel processor and ESXi2 is having AMD processor. So there is no problem here. Still we can migrate it. Okay, we have a feature called enhanced vMotion. So previously it was very difficult. In the previous versions, you must have the processors from the same family. But in the newer version, we have a concept called enhanced vMotion. So with enhanced vMotion, if the ESXi hosts are having the different processor, if they are having the processors from the different companies, it will migrate it. But better to have the same family, better to have the processors from the same company. If you don't have, no problem. Transferring or migrating the live virtual machine from one ESXi host to another ESXi host. So guys, what we will do now, we will power on this server one. Okay, because we want to migrate the live virtual machine. So let us power it on. Okay, so it is having multiple prerequisites. Okay, and we need to enable the vMotion on VM kernel port, right? So let us power on this virtual machine. We'll launch it. So let us power on this Windows Server operating system. We'll log into this operating system. So we'll configure the IP address on this Windows Server from the same network 192.168.140.0 network. Why we are configuring the IP address, I will show you. Then we'll migrate the virtual machine. So guys, this operating system is installed on the first virtual machine. It is not related to SAN. Okay, we'll configure. It is 140.55. So then let us configure the 192.DNS as well. 140.2. Okay, it is already, we have already configured the IP address from the same network. Now what we will do, we will ping the gateway. Okay, we'll continuous ping the gateway. It is pinging, and we'll do the live migration, and you will not see the drop here. Okay. So why we are pinging here? To check during the migration if this server goes down or not. Okay. So let us go to the vCenter server. And now guys, what is the prerequisite here? The prerequisite is to enable the vMotion, right? It is having multiple prerequisites. All the prerequisites are done. We need to configure, we need to enable the vMotion on VM kernel port. Okay, this option. vMotion must be enabled in VM kernel port on both the ESXi host. So what we will do, we will go to ESXi1 first, then we'll go to configure. Under configure, we will go to networking. Under networking, we will go to VM kernel adapter. So we have created some VM kernel adapters for multiple switches. So let us go with VM kernel 0. Okay, and let us remove the other VM kernel ports to avoid any confusion. We will have the VM kernel port of our default switch. Okay, so VM kernel 0 is there of our default switch, and if you see the IP address here, 140.10. So what you can do, you can click edit and you can enable the vMotion here. It will be enabled, or you can create the separate VM kernel port for vMotion. Okay, if you see the first option, VM kernel network adapter, it will handle the multiple traffics like vMotion, iSCSI, NFS, FCOE, fault tolerance, vSAN, etc. So we need vSphere vMotion. So okay, we'll go with the first option, then we'll click next. Okay, so we'll select the existing switch, which is vSwitch 0. Okay, then we'll click next, and you will select the services. Okay, so if you select multiple services, it will handle the traffic of multiple services, but we need only vMotion, and we'll label it vMotion. Okay, then we'll click next, and on VM kernel port we should configure the IP address. Okay, so if you select the first option, it will get the IP address from DHCP. If you select the second option, we need to configure the IP address right now. So we are configuring the VM kernel port on 10. So let us give 11 here. 192.168.140.11. Subnet mask 255. So we'll take the subnet mask, and it has configured the default gateway by default. If you want, you can change it as well. So we'll go with the default settings. Then we'll click next. So the VM kernel IP address is 140.10, 140.11 of ESXi1 for vMotion. Okay, you can review the settings. If you want to change, you can go back. So we are okay with these settings. Then we'll click finish. It has created VM kernel 1, and the label is vMotion. Okay, and vMotion is enabled here. Okay, if you see, we have multiple options like FT management, replication, etc. But we have enabled only vMotion. After that, we need to enable the vMotion on ESXi2. We'll go to ESXi2, then we'll go to configure. Under configure, we'll go to networking. Under networking, we will go to VM kernel adapter. Okay, so it is already having one VM. Let us remove it to avoid any confusion. Okay, so it is having. So with storage vMotion, we move the virtual machine files from one data store to another data store. Let us say we have two LUNs, LUN 1 and learn2. All the virtual machines are saved in learn1, and it is having some issues. You want to do some maintenance. So again, if you touch this data store, so there might be, you need to unmount this data store. So if you unmount the data store, the virtual machines will not be available to the users. So before doing any kind of maintenance, what you will do, you will move the files from one LAN to another LAN. So storage move motion is used to migrate a virtual machine and its files from one data store to another data store while the virtual machines are running. Okay. With storage vMotion, you can move the virtual machines for maintenance or to upgrade. If you want to upgrade this data store, or if you want to do any maintenance, at that time you will migrate the files from one LAN to another LAN. You can use storage vMotion to redistribute the virtual machines or virtual disk to different storage. So again, the guys, if you want to do the balancing here, let us say LAN2 is utilizing only 30% of resources, whereas LAN1 is utilizing 95% of resources. So for the better performance, you can move the files from one LAN to another LAN. So for storage vMotion, what we need two LANs, right? How many LANs we need for storage vMotion?
2.
Two. How many LANs we have created?
Only single.
One. So we need to create one more LAN, correct?
Yes.
So let us create LAN2. We will go to SAN. We will open the server manager. We will go to file and storage. Okay, then we'll go to iSCSI. Okay, we already have one LAN. Let us create one more LAN. We will right click here and new iSCSI virtual disk. You will select the first option. Okay, so again we will go with the select by volume option. We have 181 GB space available. We'll click next and let us provide the name to this virtual machine, this virtual disk as learn2. Then we'll click next and we'll go with dynamic expanding. Let us give 100 GB or let us give, okay, we'll go with 100 GB. Then we'll click next. And yesterday we have added the IQN numbers. Okay, so it is available here. The IQN numbers are already available. So it will select it and it will,
Sir, for LAN,
pardon?
sir, for LAN1 and LAN2 should be the different one, no?
Why different one? We are sharing the learn2 with ESXi1 and ESXi2. Got the point?
Yes.
Do we have other ESXi hosts?
No.
Okay, we will share the learn2 with same ESXi host, right? So let us click next and you can see the IQN numbers. Then we'll select create option. Then we'll close it and let us access the vCenter server. Any confusion, Rajiv?
No, sir. No, sir. Got it. If we will create new SAN, then we will give the IQN number.
Yes. Okay, then we will go to data store. Under data store, we'll go to actions. Under action, we'll go to storage and we'll click new data store. VMFS, then we'll click next and let us, so it is not available here. So if it is not available here, then we need to go to the adapter, virtual adapter. Okay, then we will dynamically find it. So here we'll go to the host, then we'll go to the configure option. Under configure option, storage adapter is there. Okay, then we select the virtual adapter, then dynamic discovery, then we type this IP address 110. It is already existing, right? Yesterday we have. Then here we will rescan the storage.
Completed.
Now you can see we have two devices. All right, learn one and the device which we have added just now. Then we'll go to ESXi1, then we'll go to data store and we'll go to action. Under action, storage, new data store. Now it should be available. You can see it is available now. Let us assign the name
Learn to
learn2. Then we'll click next. Next. So you can increase or decrease the size. Okay, so let us click next. We'll click finish. And you will see learn2 here. Okay, we have created two learns, learn1 and learn2, and both of them are shared with ESXi1 and ESXi2. Let us verify 140.20. So again, we'll go to storage, new data store. Okay, so it is not available. We need to refresh. Now it is learn2 is available on both ESXi1 and ESXi2. Now we have learn1 and learn2. Now what we will do? We will migrate the host files from one data store to another data store. Okay, so here Windows Server 1, it is available in learn1, correct?
yes, sir.
So what we will do? We will move the files of this Windows Server 1 from learn1 to learn2. So again you will right click here, you will click migrate, then which option you will select here?
Choose the storage on the second.
Second one.
Second one. Guys, you guys others are getting or not?
Yes, yes.
Preet and Rengal.
Yes, sir.
Yes, yes.
Alright.
Yes.
Alright. So we select the second option to migrate the storage. So it will move the files from learn1 to learn2. So we need to select the destination as well. So we select learn2 here. Okay, and it is having some errors. So these errors are related to CD DVD drive. So we'll click next, finish. So it has started the migration, and you can see the virtual machine is powered on. It is pinging, okay. already the migration is done. You can see the Windows server is powered on. There is no loss here. It is working fine. And let us verify the. You can see it has moved to the files are moved to learn to.
Yes, sir.
Okay, so vSphere high availability means if any ESXi goes down, the virtual machine of this ESXi host will go to the other host. Okay, so it provides the high availability for virtual machines. If any host fails, the virtual machine on failed host are restarted on alternate host. So we have two ESXi hosts, ESXi1 and ESXi2. ESXi1 is having some virtual machines, virtual machine 1, 2 and 3. ESXi2 is having, let us say, two virtual machines, 4 and 5. And if this ESXi1 goes down, okay, so the virtual machines of this ESXi1, 2, 3 will be restarted on ESXi2. 1, 2, 3, they will be restarted on ESXi2. So it is possible because of this vSphere high availability. So it provides the high availability for virtual machine if any host fails. So in this example, this host goes down and the virtual machine on the failed host. So the virtual machine of this failed host, they are moved to the other ESXi host which are working fine. And the high availability provides failover protection in case of hardware failure in our environment with some downtime. So guys, these virtual machines, they are getting restarted on the other ESXi host, which means you will get some downtime with vSphere high availability. These virtual machines will be down for few minutes. Okay, then they will get restarted on the other ESXi host. You need to remember this point. You will get some downtime with high availability, and this high availability provides the this option vSphere high availability provides the high availability against three things. The first thing is if this ESXi goes down as we have discussed, it will restart the virtual machines on the other host. You will get the high availability against the host failure. And the second thing is VM and guest operating system failure. Let us say the ESXi host is working fine. We have two ESXi hosts, ESXi1 and ESXi2. It is having two virtual machines. So both of them are working fine. But this time, let us say the problem is there in the virtual machine or operating system. So you will get the high availability against virtual machine and operating system. High availability in the sense the virtual machine or operating system, they will get restarted on the same ESXi host because this ESXi host is working fine. There is no problem with the ESXi host. Problem is there either in the virtual machine or the operating system. So it will restart the virtual machine on the same ESXi host. So VM or guest operating system failure. So VMs are started on the same host, and you will get the high availability against the application failure as well. So guys, we run the okay, we create the virtual machine. On the top of this virtual machine, we create operating system. Okay, and we install the application. Let us say the application is having some issues. So you will get the high availability against the application, which means it will restart the application on the same ESXi host. So application restarted on the same host, and applications also support high availability option. Clear. To perform vSphere high availability, the ESXi hosts must be added to a cluster, which means we need to create the cluster first. Okay, so what we will do first, we will create the cluster first. After creating the cluster, okay, you have created one cluster, then you will add the ESXi host to this cluster. So before seeing what is high availability, before seeing the high availability labs, or before seeing the high availability in detail, we need to understand what is this cluster first. So this cluster is mandatory for high availability, and it is mandatory for DRS as well. Okay, so you need to create the cluster to perform high availability and DRS. Remember this point. Okay, without cluster, you can't imagine the high availability or DRS. So you will learn what is a cluster, how it is organized, and how HA detects and respond to the host failure. So we will see how the HA will know there is a host failure or operating system failure or application failure. We'll see that as well. So in order to use vSphere high availability, you must create a cluster. So what is a cluster here? A cluster is a grouping of ESXi hosts administered collectively by vCenter server. So what we do in cluster, okay, we add the ESXi host. In this cluster, we have 4 ESXi hosts, 1, 2, 3, 4. And all these ESXi hosts in this cluster are managed by the vCenter server. This is the vCenter server. Okay, so it is managed by the vCenter server. Creating a cluster enables the host to work together. So what we are doing here in cluster, we are making this ESXi host, all the ESXi hosts work together. Work together in the sense, as we have discussed, if any ESXi goes down, the virtual machines of this ESXi host will move to the other ESXi host. So they are working together here. They are supporting each other. So creating a cluster enables the host to work together. So they provide the high availability of virtual machine. So when you enable the vSphere high availability, so after creating the cluster, you need to manually enable the HA. Okay, so it is not like you have created the cluster, high availability and DRS will start working automatically. After creating the cluster, you will add the hosts. After adding the host, you will enable the HA manually. Okay, so when you enable the HA on the cluster, this HA, it will elect one host as master host. So we have 3 ESXi hosts, and one host will be elected as master host. So what is the use of this master host? The master host communicates with vCenter server. So it will communicate with vCenter server. The other ESXi host, they are not directly communicating with the ESXi host. Master host will communicate the ESXi host, or it will inform the status of this other ESXi host to the master. So when you enable the when you enable the vSphere HA on the cluster, HA elects one master, and the master communicates with vCenter server and monitor the state of the other host. So it will monitor the state of the other ESXi host. It will check whether they are working fine or not. If it is down or if it is up, it will check it. Okay, and it will check the virtual machines as well. It will monitor the state of the other host, and it will check the status of all the protected virtual machines. Protected means running virtual machines. So it will monitor the ESXi host. It will monitor the running virtual machines on this ESXi host. So different types of host issues are possible, and the master host is responsible for detecting and dealing with them appropriately. So if these ESXi hosts are having some issues, let us say it is down. So this master host will responsible to move the virtual machine from one host to another host, or it will inform the vCenter server. vCenter server will move the virtual machines from the dead ESXi host to the working ESXi host. We have created the cluster and we have enabled the HA. So when you enable the HA, one master will be selected, master host. This master host will monitor the other ESXi host. So how it will monitor it? Okay, so what it will do, it will send the heartbeats, or we can say it will ping the other ESXi host. So it will send the heartbeat to whom? It will send the heartbeat to the VM kernel port. VM kernel 0. Okay, all the ESXi hosts are having VM kernel 0. So this master host, it will send the heartbeat. So the sending of heartbeats to VM kernel port is known as network heartbeats. So it will send the network heartbeats to all the devices. If it is receiving the response, which means all the ESXi hosts are working fine. So the master host can detect the host failure. Okay, how it will know that there is a failure, there is some issue in the ESXi host. Let us say this VM kernel goes down. Okay, so it will think that there is some issue, but it will not consider this host as a dead host. So what it will do, if it is not receiving the heartbeat from VM kernel 0, it will start sending the heartbeat to the storage. Okay, so it will start sending the heartbeat to the storage. If it is receiving the response from the storage, this ESXi host, okay, which is not sending the heartbeat from VM kernel port, it will be isolated. Isolated means still VMs will be working on this ESXi host. Only the issue is with the VM kernel port, because it is getting the heartbeat from the storage. So VMs will be running. Okay, so how to fix this issue if it is not getting the heartbeat from VM kernel port? Any idea how to save this ESXi host to be isolated? Okay, because it is not getting the response from VM kernel port, it is getting the response from the storage here. This machine will be isolated because it is not receiving the response from VM kernel port. It is not getting the network heartbeats, so it will be isolated. So guys, how to avoid this ESXi host to be isolated? Any idea? Anyone?
So we can add one external VM kernel port.
Very good, beautiful. So what you will do, you will configure the redundancy here. You will configure two VM kernel ports. If it is fail, this master will get the heartbeats from the other VM kernel port. Very good, Rajiv. Clear? Let us say it is not getting the heartbeat. So here you can see VM kernel port is responsible for network heartbeat. If the network heartbeat is not received, it will be only isolated. Still, the virtual machines will be running on this ESXi host. They will not be moved to the other ESXi host. Okay, that is the problem is there, but VMs are not restarted on the other host because it is still receiving the data store heartbeats or storage heartbeats. Isolation can be avoided by configuring the redundant management network. So you will configure the redundancy here. You will create two VM kernel ports so we can avoid the isolation. So guys, if you see, this master host is not receiving the network heartbeat, it is not receiving the heartbeat from VM kernel port, and it is not receiving the heartbeat from the storage as well. In this case, it will consider this ESXi host as dead host. Then it will restart the virtual machine of this host on other ESXi host here. So both heartbeats must be down to restart the virtual machine on other ESXi host. So cluster configuration information is maintained by VPDX process. Okay, it is a vCenter process and it is maintained by this process only about the cluster information, and it is updated to master. So vCenter server, it will update it, and vCenter server has the cluster information which is shared by master, and this other ESXi host, they are referred as slaves. Then this information will be shared with the slaves. Alright. So guys, you can configure how a vSphere HA reacts to the host failure or network isolation. Okay. So let us say if the host is failed, what the action should be taken. If a host is failed, its virtual machine needs to be restarted on other host. When it restarts the virtual machines, high availability begins with those with highest priority. So guys, let us say this ESXi host is having some virtual machines, and you have given some priority to these virtual machines like high priority, low priority, medium priority, and again high priority. So you will decide here, okay, when this host goes down, which virtual machine should be moved first, low priority virtual machine or high priority virtual machine. Okay, so when if a host fails, its virtual machine need to be restarted on other host. When it restarts the virtual machine, high availability begins with those with highest priority, continuing to those with the lowest priority until the virtual machines are restarted or no more cluster resources are available. So what it will do by default, it will start with the highest priority to low priority. Okay, so it will restart all the virtual machines on the other ESXi host till all the machines are restarted or the resources are not available on ESXi2. So you can select the order. Okay, as we have discussed, you can select the order like which machine should be restarted on the other ESX, low priority virtual machine first or high priority virtual machine first. This is the option here. Okay, this option is VM restart priority. So it is having low, medium and high. If you select low, low will be started first. If you select medium, medium will be started first. If you select high, high will be started. So obviously you will select high priority virtual machine first. How to deal with isolation when the ESXi host get isolated. So what should we do? We have multiple options. So if a host becomes isolated or it is not getting the network heartbeats, so it is still running the virtual machines. It is still running, guys. It is not the VM kernel is not sending the heartbeat. It doesn't mean this host is down. Okay, still it is running, but the problem is there with the VM kernel port, but has lost the management network connectivity. So high availability uses host isolation response setting to determine what happened to the affected virtual machine. So it will see the virtual machines were working fine or not. So guys, we have three options. If the ESXi host is isolated, let us say this ESXi host is isolated, and what should we do this with this ESXi host? So if you select the first option, powered on, by default it is powered on, which means all the virtual machines will be working on this isolated ESXi host. If you select the second option, power off then failure. So what the HA will do, it will turn off all the virtual machines and it will move all the virtual machines from this isolated ESXi host to another ESXi host. This is the meaning of power off then failover. The third option is shut down then failover. So what it will do, it will shut down the virtual machines, then it will do the failover. Guys, what is the difference between power off and shut down here? Anyone? Power off and shut down, what is the difference here? Okay, what is shut down?
It's complete shutdown, I think.
We shut down. We use this option to shut down the computer, right? You will go to start and you will select this option to shut down. Correct?
We
So
manually initiate shutdown, power off automatically.
no. This is the shutdown. This is the shutdown option. Power off means you are pulling off the power cable, or you are continuously pushing the power cable, power button to shut down the computer. Got the difference between power off and shutdown? Shutdown means it will use this option to shut down. Power off means you will press the power button to shut down the computer or power off the computer, or you will pull the cable. If you pull the cable, what will happen? If you pull the power cable of a computer, what will happen? It will
shut
power
down.
off, right? Now guys, as we have discussed, we need cluster for HA. After adding the ESXi host to the cluster, one ESXi host is selected as a master host. So on what is the criteria to select this host as master host? Let us try to understand. So any ESXi host is having maximum number of data stores. Let us say these ESXi hosts are having only learn1, or let us say learn1, learn2. It is also having learn1, learn2. But this master host is having learn1, learn2, learn3, learn4. So it is having the maximum number of data stores. So this host will be selected as a master host. So maximum number of data store. If the data stores are equal on all the ESXi hosts, then it will check the highest MOID. So manage object ID is provided to all the ESXi hosts by vCenter server. So it will see the highest MOID and it will make, let us say it is having the highest MOID. So it will become the master here. Okay. So who will get the highest MOID? First added host to the cluster will get the highest MOID and it will become the master. And guys, we have discussed like you will get the high availability against the failed ESXi host. You will get the high availability against the guest operating system and VMware failure, and you will get the high availability against the applications as well, right? So when we enable the VM and guest operating system features, it uses the VM monitoring tool. Okay, if you remember, we installed the monitoring tool, okay, VMware tool. So it will use that tool to check the heartbeat. HA will use the tool to check the heartbeat of operating system and virtual machine. We are not talking about ESXi host here. So we have discussed about the ESXi host. We are discussing about virtual machine and operating system high availability. So who is checking the heartbeat here? VMware tools. Okay, you need to install the VMware tools, then only it will check the heartbeat of this virtual machine and operating system. So it uses the VMware monitoring tool which monitors the virtual machines. If any virtual machine fails, it will report to HA agent. So we have high availability agent. Okay, when you enable the high availability, it will have the high availability agent. So this tool will send the update to high availability agent. High availability agent restart the virtual machines on the same ESXi host. So VMs are restarted on the same host. VM tool installed a VM heartbeat service. So whenever we install the VM tool, it will install the VM heartbeat service which will exchange the heartbeat with HA agent. If vCenter server is out of service, let us say vCenter server is not working, but all the services work according to the rule, there will be no impact. And you should have at least 2 ESXi host in the cluster. Okay, if you have only one ESXi host, so there is no high availability. You can't perform the high availability. So at least you should have 2 ESXi hosts. And till vSphere 5.5, each cluster support maximum 32 hosts, which means you can add 32 hosts in each cluster till 5.5, and you can run 512 virtual machines per host and 3000 virtual machines per cluster. Okay, and here overall you can run 3000 virtual machines per cluster. From 6.0 onwards, vSphere 6.0 onwards, you can add 64 hosts, 8000 virtual machines per cluster. Okay guys, so this is the high availability for you. Today we will start a new topic, DRS, and it is very important topic. DRS stands for Distributed Resource Scheduler. What is the use of this DRS? It balances the resource utilization across the cluster nodes. So we'll discuss what is the meaning of this sentence in detail. Okay, so let me open the paint. Imagine you have 3 ESXi hosts. Okay, ESXi1, ESXi2, ESXi3, and ESXi1 is having 3 virtual machines, 1, 2, and 3. ESXi2 is having 2 virtual machines, 4 and 5. ESXi3 is having only 1 virtual machine, which is VM6. ESXi1, it is utilizing, let us say, 50% of resources. All right, and let us say it is having 2 virtual machines, 6 and 7, and ESXi2 is utilizing, let us say, 60% of resources, and ESXi3 is utilizing around 90% of resources. Okay, so what this DRS will do, it will try to balance the resources. Okay, it will not do the balancing based on the number of virtual machines. It will see ESXi1 is utilizing only 50% of resources. ESXi2 is utilizing 60% of resources. ESXi3, even though it is having two virtual machines, it is utilizing 90% of resources. Then what it will do? It will move one virtual machine from ESXi3 to ESXi1. Okay, it is overutilized ESXi host, whereas ESXi1 is underutilized host. So it will move one virtual machine from ESXi3 to ESXi1. Let us say 6 is moved to ESXi1. Now, let us say the balance, let us say it was utilizing 30% of resources. So it has moved here. Now it will utilize 80% of resources. Okay, and here let us say it was utilizing 20% of resources. Okay, so now it will utilize 70% of resources, and this virtual machine will utilize 70% of resources. So it will balance the ESXi host based on the utilization of resources. Resources in the sense RAM, CPU, and hard disk, etc. Okay, so it is used to balance your cluster. So DRS, it balances the resource utilization across the cluster nodes. Cluster, okay, you need to create the cluster and add the ESXi host to the cluster. So in our previous labs, we have already created the cluster to perform HA, and we have added the ESXi 1, 2, and 3. So DRS also required the cluster, and it has two types of DRS. Okay, DRS is having two types. One is normal DRS, whereas the other one is storage DRS. What is the difference between DRS and storage DRS? DRS will check the ESXi host utilization, whereas storage DRS will see the storage utilization. We will discuss about the storage utilization later. So in this example, if you see, we have three ESXi hosts: ESXi1, ESXi2, ESXi3. 2 is utilizing its 100% of resources, even though it is having only two virtual machines, but it is utilizing the 100% of resources, whereas ESXi3 is utilizing only 20% of resources. So what this DRS will do, it will monitor the things and it will see there is imbalance in the network, then it will move the virtual machine from overutilized ESXi host to underutilized ESXi host, and it will do the live migration, and it uses the vMotion technology. Okay, so in vMotion we move the virtual machines manually. With DRS will move the virtual machine automatically. Again, it is using the vMotion technology to move the virtual machines. So vMotion is done manually when there is no balance of resources in ESXi host. DRS does it automatically. In vMotion and DRS, CPU and RAMs. So what it will migrate? It will migrate the CPU and RAM. Let us discuss about storage vMotion. As we have discussed, DRS is having two types. One is normal DRS, another one is storage DRS. In normal DRS, virtual machines are moved from overutilized ESXi host to underutilized ESXi host. Let us see what is this storage DRS. So for this storage DRS, you need at least two LUNs or two data stores. And what this storage DRS does, it migrates the files from one data store or from one LUN to another LUN. So if you have more LUNs, you will get more high availability. Let us say in this example, we have three LUNs, LUN 1, LUN 2 and LUN 3. LUN 1 is utilizing 100%, okay, it is 100% full, whereas LUN 2 is 80% full and LUN 3 is only 30% full. Against storage DRS or DRS will monitor the storage here and it will see that LUN 1 is overutilized whereas LUN 3 is underutilized. So it will move the files, virtual machine files from LUN 1 to LUN 3. It is moving the files from LUN 1 to LUN 3. So this is the storage DRS. So again, at least you need two LUNs here and it will migrate the files from one data store to another data store. If you have more LUNs, you will get the more high availability. Okay, so if one data store is utilized more resources, then DRS moves the file to another data store. And DRS keeps an eye on data store to avoid out of space condition. So it will check the storage, it will keep an eye on all the storage to avoid the out of space condition. If the utilization of data store reaches a configured value, DRS may be recommended more virtual disk of this storage. So if it is reaching, okay, if all of them are full, it will request you to add more storage. DRS is having affinity and anti-affinity rules. It is having two rules, affinity and anti-affinity rules. What is the meaning of affinity rule? Let us try to understand. So affinity rules, VMs must run on the same machine. Guys, let me open the notepad. Imagine we have only two ESXi hosts. ESXi1, ESXi2. Okay, in every environment, you have some virtual machines which are dependent on each other. Like we have web server, we have installed web server on one virtual machine. So this web server is dependent on database server. Okay, and it required the Active Directory as well or domain controller. Let us say Active Directory. So these three virtual machines are dependent on each other. If one virtual machine goes down, the other two virtual machines will not work. Database goes down, there is no use of web server. So these three virtual machines should work together. Okay. Now, let us say we have created three virtual machines and we have installed web server, database server and Active Directory on ESXi1. And what is happening here? It has utilized, let us say 70% of resources, or let us say it has utilized 50% of resources, whereas ESXi2 is utilizing only 10% of resources. Now what the DRS will do? To do the balancing, it will move the virtual machine. Let us say it has moved two virtual machines, Active Directory and database. Active Directory and database on ESXi2, and this ESXi2 goes down. What will happen, guys? Will this web server work alone?
No,
No.
sir.
There is no use of this web server, right? Because
Yes.
the DRS has moved the virtual machines from one ESXi host to another ESXi host. This is the problem here. So what will you do? You will make, you will group all these virtual machine. Okay. Database, an active directory, and you will group all these three virtual machine, and you will create one affinity rule. Affinity rule means we will tell the DRS, if you are moving the virtual machine, move all the virtual machines together or do not move it. Even if it is having 10%, okay, either it will move all the virtual machines on ESXi2 or it will not move it. Got the point?
Yes, sir.
Yes, sir.
So what is this affinity rule?
We will group some virtual machine so that it can move
Together, okay, they
like
will
one
stay on the same
ESXi
ESXi host. Okay, either all these three virtual machines on ESXi1 or all these virtual machines on ESXi2. Got the point?
Yes.
Preet,
Yeah.
what is this affinity rule? Any doubt? Rangal Ahmed, what is this affinity rule?
Well, it will group the virtual machines together, and if they have to move, they will move all together, or they won't move.
Or they will not move, right? They will stay on the same machine. This is the affinity rule. Either move all the virtual machines in this affinity or do not move it. Clear?
Yes, sir.
Yes.
Now guys, this environment is having one issue. Just give me 2 minutes and we'll continue. Alright. So guys, if you see in this example, do you see any problem? Any drawback? Anyone? In this environment, do you see any drawback here?
Yes, sir.
What is that?
If
Um,
any,
Pardon?
if there
if
is
we-
any outage or issue, entire
Very good.
virtual
So if you see, if this ESXi1 goes down, the entire network goes down, correct? So to avoid it, what we will do, we will create one more web server. Okay, we will create, you can say, the cluster here. Okay, in this cluster we will have one more web server, one more database virtual machine, and active directory machine. So if this ESXi1 goes down, users will access the web server from the other ESXi, correct? Even if it is this virtual machine goes down, the users will be able to access the web server from ESXi2. If database goes down, we have database 2 here. So users will be able to access the database from the other ESXi. If active directory goes down, users still can access the active directory, correct? If it is good now, guys, any doubt? Is it clear or any confusion?
It's clear, sir.
Others?
Sir, once again, please.
Okay. Previously, we have only one web server, one database server, and one active directory. All of them are dependent, correct? So we kept them in affinity rule. So wherever they go together, correct?
Yes.
So affinity rule, it will move the virtual machines together. But let us say, if this ESXi1 goes down, what will happen? The network will down or not? Because we have only one web server, one database, and one active directory. Clear? So what we will do, in the cluster, you will create 3 more virtual machines. Okay, if this web server goes down, user can access the web server from other ESXi host, correct? If this database goes down, user can access the database from the other server. If active directory goes down, users can access the active directory from the other host or not. Clear, Rajiv?
Yes. Yes, sir.
In this situation, everything will be working fine, correct? Okay.
Yes.
If this web server goes down, what will happen? Will the network down? Will the website down? Pardon?
Yes. Website will be down, sir. Database.
How? Website is here, right? If one website, sir, if this virtual machine goes down, we have the cluster. Okay. In that cluster, we have one more web server or not?
Yes. See, they can use from the second year.
Yeah. That is why we have created the cluster. In the cluster, we have created one more web server, database to an active directory too.
I got it.
It is clear, right? Now,
Yes.
let us say this machine, okay, ESXi2, again it is utilizing 10% of resources, and ESXi1 is utilizing 50% of resources. Now, what the DRS will do, let us say we have not configured the affinity rule. What this DRS will do, it will move from some virtual machine, like it has moved active directory from ESXi1 to ESXi2. So ESXi2 is having how many active directories?
2.
2 active directories. And let us say this ESXi goes down. What will happen? The network will go down, right? So it required one active directory, and this active directory is moved to ESXi2. Now the network will not be available to the users. Is it clear or not? You are getting the point?
Yes.
Yes, sir.
Okay. So what
one,
we, pardon?
one question.
Mhm.
When you do the affinity rule and on EXXi1 and
Mhm.
2, they both got all the web server active directory, and so
No. Let us say affinity rule is not configured.
okay.
Okay. Here we have not configured the affinity rule, and it has moved the virtual machine. So active directory from one ESXi to another ESXi to another ESXi, and this ESXi goes down.
I
And
understand this bit.
okay, you have understood, right?
Yeah.
Now, will it work? Will this website work? Is it Ahmed?
Yeah.
No.
Yeah, Ahmed. Will this website work?
Well, the website will work, but not the Active Directory, I think.
Yeah, Active Directory. This website is dependent on Active Directory, right?
Yeah.
So it will not work because it is moved to
Yeah.
ESXi2. So in some situations, what we do, we should not run the two virtual machines together. Okay, that is called as anti-affinity rule. So what should we do? We should configure, okay, the Active Directory 1 and 2 in anti-affinity rule, which means if there is imbalance, there is disbalance here in ESXi2, the DRS should not move the virtual machine from one ESXi1 to ESXi2. Instead of, it should move the virtual machine to another ESXi. Let us say it should move here. Active Directory 2 should be moved here. Okay. So you should keep web server 1 and web server 2 in anti-affinity rule. Database 1 and database 2 in anti-affinity rule. And Active Directory 1 and Active Directory 2 in anti-affinity rule. So whenever DRS is moving a virtual machine, it should not be moved to ESXi2. Instead of that, it should move to another ESXi host. Okay. So affinity rule means the virtual machines run together. Okay. These virtual machines should be moved together. Anti-affinity rule means the virtual machines should not run on the same ESXi host. Clear the point? What is affinity rule? Guys, what is affinity rule? What is the meaning of affinity rule?
VM must run on the same machine.
Anti-affinity rule?
Just opposite, not
Opposite. They should not run on the same
on the same.
machine. Ahmed, Preet, Ringal, any doubt? Any
No,
confusion?
understand now.
Understood, right? Preet and Ringal, any doubt?
No.
No, sir.
It is clear, right? Mhm.
One quick question. When you
Okay,
do
Ahmed.
the anti-affinity rule, do you
Mhm.
need to have more than 2 ESXi hosts?
Yeah, we should have more ESXi hosts.
Okay.
Okay, so but in real network, you will have multiple ESXi hosts. Okay. So if you see here, affinity rule means virtual machines must run on the same machines. Okay, A and B, they should run on the same machine. Anti-affinity rule means virtual machines must not run on the same machines. So if you want to run affinity rule, VMs on the same host. If you want to run certain virtual machines together, like database, web server, and domain controller, to run on the same host, we should use affinity rule. Anti-affinity rule, redundant, same virtual machines should not be on the same host, like database 1 and database 2. If you run both of them on ESXi, same ESXi, if this goes down, your network will be down. Okay, so we should configure database 1 and database 2 in anti-affinity rule. Okay, and for DRS, we must have the enterprise plus licensing. Okay, this is the prerequisite. But in we are using the trial version, so you will get all the licenses. Then guys, in storage also we have affinity rule and anti-affinity rule. Okay, let us say we have like affinity rule. In the affinity rule we have database and web server files on the same data store. Okay, so either they will move to the same data store or they will stay on the same data store. Okay, it is not move database in one store and web server in another data store. So either they will stay together or move together. This is the affinity rule similar to our previous example.
Same concept when we are
Same
using
concept
the
in data store as well.
okay.
Okay. So anti-affinity rule. No, let us say you have two database files, database 1, database 2. So anti-affinity rule, it will run, it will keep database 1 in one data store and database 2 in other data store. Okay. They will not be on the same data store. Why? If one data store goes down, both of them will be down. What the DRS will do, it will do the initial placement. Initial placement means, let us say you have multiple virtual machines, VM1, VM2, VM3, VM4, VM5, and you have 3 ESXi hosts. Okay. So when you power on all the virtual machines, VM1, VM2, VM3, VM4, VM5, what the DRS will do, it will do the initial placement. Okay, it will see we have 3 ESXi hosts, VM6, then it will put VM1, 2 in ESXi1, 3 and 4 in ESXi2, 5 and 6 in ESXi3. So it will do the initial placement when we power on any virtual machine. Okay. So DRS will do the initial, DRS will take the decision where to place the virtual machine. Is it clear? Clear, guys?
Yes.
What the DRS will do?
Yes.
Okay.
Yes, sir.
We'll see that lab as well. And the second thing is, it will do the load balance of virtual machine using load vMotion. We have already discussed. Okay. What it will do, it will move the virtual machines from overutilized ESXi host to underutilized ESXi host. It will balance the environment. The second thing is, it will do the load balancing of running VM using vMotion. So guys, it will use vMotion technology. It doesn't have any other technology to move the live virtual machines. It will use the existing technology vMotion. vMotion moves the it will migrate the live virtual machine from one ESXi host to another ESXi host. So it uses the vMotion. And DRS is a cluster required vCenter server. Okay, and criteria of load balancing is to divide the CPU and memory load. So it will see the CPU utilization and memory utilization to do the load balancing. And we can add 64 clients in DRS and high availability. Okay. So guys, as we have discussed, we need the cluster for DRS and high availability. So we can add 64 ESXi host in the cluster. Okay. And it will not consider the down virtual machines. So it will see the live virtual machines. Okay. These live virtual machines are balanced or not. If it is not balanced, then it will move the live virtual machines only. It will not consider the down virtual machines. So if you see here, it is doing the load balancing based on the CPU and RAM utilization. So all these virtual machine, all these ESXi hosts are in a cluster. Okay, the total RAM size is 520 of all the ESXi host, and the CPU is 50 gigahertz. ESXi1 is utilizing 6 gigahertz CPU and 80 GB RAM, and ESXi2 is utilizing 12 gigahertz and 120 GB RAM. ESXi3 is utilizing 14 gigahertz CPU and 160 GB RAM, and ESXi4 is utilizing 16 gigahertz and 160 GB RAM. So the ESXi host, okay, they are not balanced here. So in this situation, the DRS will migrate the virtual machines from overutilized host to underutilized hosts. So virtual machines are not balanced. So we have discussed the points already what the DRS will do. The same thing is mentioned here. It will balance the virtual machines by migrating the virtual machines from overutilized ESXi host to underutilized ESXi host. So guys, it will do three things. As we have discussed, DRS will perform three things. The first thing is it will do the initial placement of virtual machines. When you power on the virtual machines, it will decide where to start, on which ESXi host to start that virtual machine. And the second thing is it will balance the virtual machines. And the third thing is it will do the power management of using distributed power management. It is having one feature called DPM, distributed power management. So what is this distributed power management? Let us try to understand. The third thing is it will do DPM, distributed power management. Imagine you have some ESXi host in your network. Okay, you have hundreds of ESXi hosts, ESXi 1, 2, 3 and 4. Okay, and at daytime you have good amount of traffic. Okay, but at night ESXi 2 is ESXi 4 is utilizing only 10% of resources. ESXi 3 is utilizing 1% of resources. ESXi 2 is utilizing only 2% of resources, and ESXi 1 is utilizing 5% of resources. Okay, all these virtual machines are underutilized at night. So what this DPM will do, it will shut down ESXi 4, 3 and 2, and it will move the virtual machines from all these ESXi host to ESXi 1, and it is used to save the power. Okay, they are underutilized at night. Why? To power on this ESXi's. Okay, so what the DPM will do, it will move the virtual machines from these three ESXi hosts to one. In the morning, it will again migrate the virtual machines to the other ESXi host. Clear guys, what is the use of this DPM? It is used to save the power by shutting down the ESXi host when they are underutilized. Is it clear or not?
Yes,
Yes.
sir.
Anyone?
Yes, sir.
What is DPM? Can anyone explain what is DPM?
DPM is used like during the night times or when the resources are underutilized.
Mhm.
The machines will be moved to one ESXi,
Mhm.
and in the morning it will be migrated again.
Very good, very good. Now guys, this option DPM is not used. Okay, mostly it is not used in real networks. Okay, this virtualization, okay, it is already saving the powers. It is already saving the power. Let us say you have migrated all the virtual machines. This DPM has migrated all the virtual machines in ESXi 1. In the morning, let us say it could not migrate the virtual machines to the other ESXi host. Okay, there will be a problem for you. Okay, so it required so many configuration, and the ESXi host also should support the DPM. Okay, these virtual machines should be powered on automatically. There are so many things. Then only we can successfully use this DPM. Okay, so that is why most of the organizations avoid using this DPM feature. Okay, as a network engineer, as a vSphere administrator, our priority is to make the virtual machines available 24/7. It should not be our priority to save the power. If you try to save the power, you will lose the connectivity. Okay, if you try to save the power means there will be a problem for us. And virtualization is already saving the power. Okay, so we should not use this DPM feature. So power management of DPM, it saves power at non-working hours. VMs work with minimum or less resources. DRS checks the load. Okay, why there is need of to run 8 hosts. Okay, so it will see, okay, why to run the extra virtual machines when it is underutilizing them. Then it will shut down the ESXi host and it will move the VMs to the one ESXi host. Okay, in the working hour, it utilizes resources, but the machines are powered off. This is the problem here. So servers should support, there is a feature called ILO, they should support this feature. Okay, and then only it will power on the virtual machines. If the machines are failed to power on, there will be a problem for you. So it is avoided in production and it is used in testing environment, but it is avoided in production because in production our priority is to make the network available. And anyhow, we have already saved the power with virtualization. We are saving the power 60 to 70%, right? Okay, so it is enough. Anything? Yeah. And guys, the prerequisites for DRS, you need vCenter server. This is the first prerequisite. Then you should create the cluster. Under this cluster, you will add the ESXi host, then you will enable the DRS. Okay, so DRS will use vMotion or not? DRS will use vMotion.
Yes.
Okay, so we need to enable the vMotion. Enable vMotion. And the fourth prerequisite is you should have the shared storage. Without shared storage, this DRS is not going
Shared
to work.
storage means LAN, no?
Yeah, LANs. Okay, we have two ESXi hosts. We have created LAN. So these two ESXi hosts should use the same LAN. Okay.
Okay.
This is the meaning of shared storage. Shared means the same LAN should be used by ESXi1 and ESXi2. This is the meaning of shared storage. Got the point?
Yes, sir.
And you should have the DRS license as well. So these are the 5 prerequisites. Let us see the prerequisite. We need the vCenter server, correct? We need the vCenter server or not?
Yes, yes, yes.
So we already have vCenter server. We need shared storage, correct? We
Yeah.
already have shared storages. Then we need the DRS license. So we already have, we are using the trial version. So we have the DRS license. Then we need the cluster. We already have the cluster or not? For HA, we have created one cluster. Then we have added the host to the cluster, correct?
Yes.
Now to perform the DRS, we need to enable the DRS on cluster. Okay, so we need to do this task now. How to enable the DRS? We'll access the vCenter server. We'll go to cluster. Okay, we'll not go to host. So these are the hosts. Okay, these hosts are under cluster. This is the data center. So we'll go to the cluster. Okay, then we'll go to configure. Under configure, we will have DRS, vSphere, DRS, and vSphere high availability. High availability is already enabled in our previous sessions. We need to enable the DRS. So we'll go to vSphere DRS. We'll click edit. Then we will enable DRS. Okay, so we'll click OK. The DRS is enabled. And guys, it is having multiple options. If you see here, the first option is automation level. Automation level, it is having 3 options. Fully automated, partially automated, and manual automated. So guys, if you remember, what is the responsibility of DRS? It will do three things, right? Remember those 3 things. what the DRS will do? It will perform three things.
Load balance.
It will, okay, load balance. It will load balance the ESXi host.
Yeah.
And what is the second task? It will decide where to power on the virtual machine, correct? When you power on the virtual machine, DRS will take the decision or not on which ESXi host it should be powered on, correct?
Yes.
Powered on virtual machine. And what is the third task?
Priority will be there. One.
Power management, correct?
Yeah, power management.
So power management, as we have discussed, we don't use in our real networks. So mainly it will do the load balancing and it will power on the virtual machine. Okay, so powered on virtual, it will place the powered on virtual machine. It will decide where to place that virtual machine when you power it on, correct? Let us say we have VM1 and we have three ESXi hosts, ESXi 1, ESXi 2, ESXi 3. When you power on this virtual machine, DRS will decide, okay, where to place this virtual machine on ESXi 1, ESXi 2 and ESXi 3. Got the point? This is the meaning of placement after powering on the virtual machine. So guys, if you select fully automated, okay, the automation level fully automated, so what the DRS will do, it will automatically decide where to place the powered on virtual machine. Okay, and the second task, it will do the load balancing. Okay, it will balance your environment. It will do it automatically. You are not going to do anything. Okay, no human intervention if you select the first option. Okay, let us try to understand what does it mean with practical. So let us select the first option and we will select aggressive mode. Aggressive mode means if there is slight disbalance in the ESXi host, it will do the migration. Okay, this is the aggressive mode. We'll discuss what is this conservative mode. Then we have level 3. Then we have aggressive mode. Okay, we'll go with aggressive mode. Then we'll click OK. Let us verify the behavior of DRS. We'll go to cluster. Under cluster, we'll go to VM. We have selected fully automated. Now guys, if you observe here, we have multiple virtual machines. Private VM, virtual machine for switch 1, VM for switch 1, VM1, VM2, VM3, VM4, and we are not going to touch this vCenter server. Then we have Windows Server 1. These virtual machines are placed in different ESXi hosts. Okay, some virtual machines are in ESXi 1, VM1. It is in ESXi 2, VM2 is in ESXi 3, and VM3 and VM4 they are in ESXi 1, and vCenter server it is in ESXi 2. We will not touch it. And let us verify the other virtual machines. So if you see, these three virtual machines are in ESXi 1. What we will do, we will shut down all the virtual machines except this vCenter server. We will not touch vCenter server. Let us shut down all the virtual machines. So remember two things. DRS will do two things. When we power on the virtual machine, it will decide on which ESXi host to place this virtual machine. This is the first task. So we are verifying the first task. Okay, let us power off all the virtual machines. We have selected all the virtual machines. Then let us power off all the virtual machines. So it is powering of the virtual machines, and if you see the status, power off. Okay, it will be power off. Alright, we'll refresh it. Okay, these two virtual machines are still powered on. Okay, still they are powered on. We'll wait for them to be powered off. Okay, all the virtual machines are powered off now. VM4. Okay, let us power it off. Okay, it is also powered off. Now what we will do? We will migrate all the virtual machines to ESX7 to 192.168.1.140.10. Okay, some of them are in 20, some of them are in 30. So we will move them to 10. So let us select all the virtual machines one by one except vCenter server. In same power state. Okay, it is saying that it is powered on. Okay, so let us ignore VM3 or let us try to power it off one more time. Okay. We will migrate all the virtual machines to 1.10. On 40.10. Okay, all the virtual machines. Okay, it is not accessible. VM2 is not accessible. So what we will do? We'll remove it. Okay. If it is not working, let us remove it to avoid any confusion. Okay, if you see, all the virtual machines are in 1.10 except this vCenter appliance. Agree or not? Guys, is it clear what we are doing here? We have moved all the
Yes, sir.
virtual machines to ESXi1, correct? Now what we will do?
Yeah.
We will power on all the virtual machines. When we power on the virtual machine, DRS will check all the ESXi host. It will see the resource utilization. Based on that, it will keep some virtual machines in 10. It will move some virtual machine in 20. It will move some virtual machine in 30. Okay, this is the meaning. Okay, when we power on the virtual machine, DRS will decide where to start the virtual machines. Let us power on them. All of them are in 10. If you observe, all of them are in 10 except vCenter appliance, and we are not touching vCenter appliance. We will power it on. And guys, it is having one more condition. vMotion should be enabled because DRS uses vMotion to migrate the virtual machines. Okay, so we have already enabled the vMotion on VM kernel in our previous labs. And if you observe here, some virtual machines are in 20, some virtual machines are still in 10. Okay, still it is powering on some virtual machines. Let us see where it will place them. Okay, let us refresh. So if you observe here, DRS has restarted some virtual machines in 10 itself, and it has moved some virtual machine in 140.20. Okay, and I think due to some reasons it has not moved some virtual machine in 30. Anyhow, this is not our concern. Our concern is to see, our requirement is to see whether the DRS is deciding where to place the virtual machine when we power them on. Alright, so let us verify the second task of DRS, which is load balancing. Okay, so for that, what we will do, again we will move all the virtual machines to ESX7 live virtual machines. Okay, let us do the vMotion, and we will make ESX7 overutilized. Right click, migrate, yes, change resource only. It is taking some time, yes. Then we'll click next. Let us move all the virtual machine to ESX7, and we will overutilize this ESX7 to verify it. Okay, for our lab, what we are doing, we are overutilizing ESX7. Then we'll run DRS. DRS will check all the ESXi hosts, and it will find that ESXi1 is overutilized. Then it will move the virtual machine from ESXi1 to 2 and 3 to balance it. So it is migrating. Okay, all the virtual machines are live virtual machines. They are powered on. Okay, so VM3 it is not relocating. Okay, VM3 is having some issues. Okay, so what to do? We will shut it down, power it off, and we'll migrate the power off. Okay, no issues. Okay, so most of the virtual machines are in ESXi1. Okay, if you see, most of them are in 10, which means ESXi1 is overutilized. So after 5 minutes, DRS will run its calculations, and it will find that ESXi1 is overutilized. Okay, either you will wait for 5 minutes, or you can run the DRS manually. So what we will do, we will go to okay, we will go to monitor. Under monitor, we will go to vSphere DRS. Under vSphere DRS, we'll go to recommendation. To run the DRS manually, we will select this option, run DRS now. And then we'll go to virtual machines. Okay, so now it will run the DRS on all the 3 ESXi hosts, and it will find that ESXi1 is overutilized, and it will move some virtual machine from ESXi1 to other ESXi hosts. Okay, so if you see, VM1 is moved to 20, VM3 it was already there in 20, VM4 is also moved to 20, and vSphere it was already there in 20. Okay, let us see some other virtual machines. Okay, so these virtual machines, okay, they are still in 10. So it will run the DRS calculations and it will move the virtual machines. Is it clear, guys? It is not moving the virtual machines to 30, so it is this 30 might be having some problem, but it is moving the virtual machines. Okay, it is trying to balance the environment. Okay, guys, any doubt till here?
No, sir.
No, so
All right. Now, guys, let us see some DRS options. Okay, so we have verified the DRS, and if you go to configure, under configure, you will go to DRS, and if you select this edit option, so as we have already seen, okay, what is fully automated. Let us see partially automated. What this partially automated will do, DRS automatically places the virtual machine on the host at VM power on. But migration, so what this partially automated will do, guys? So again, what are the two tasks of ESXi or the DRS? It will power on the virtual machine on different host, correct? Power on VMs. When you power on the virtual machine, it will take the decision on which ESXi host this virtual machine to be placed. The second task is it will do the migration automatically. It will do the load balancing, you can say, in your environment. So if you select the fully automated option, it will do both the tasks. Okay, you are not going to do anything here. If you select the partially automated option, it will power on the virtual machine on different ESXi host automatically. Okay, power on virtual machines on different ESXi host automatically. But for load balancing, it will give you the suggestions. Okay, it will tell you that VM1 should be placed to ESXi2, VM3 should be placed to ESXi3, okay, VM4 should be placed to ESXi2, something like this. It will give you the suggestion. It will not migrate the virtual machines automatically. If you select partially automated option, okay, fully automated, it will take the decision for both the tasks, but partially automated, it will take the decision for first task, and for load balancing, it will provide you the suggestion, and you are the one who will decide whether to accept the recommendation of DRS or not. And let us verify it. So what we will do, we will select partially automated option. Then we will click OK. Okay, so again, to verify the first task, we need to power off all the virtual machines. We'll power off all the virtual machines and we'll move all the virtual machines to ESXi1. Then we will power it on. We have selected partially automated option. So it will, when we power on the virtual machine, DRS will decide where to power it on which machine these virtual machines should be powered on. Okay, so all the virtual machines are powered off. Let us move them to ESXi1. We are doing the cold migration here. Cold migration means virtual machines are powered off and we are migrating them. Let us move all the virtual machines to ESXi1. All the virtual machines are in 140.10. Okay, if you see the last octet, except appliance, vSphere appliance, all the virtual machines are in 140.10, all of them are in ESXi1. Let us power them on. We have selected the partially automated option. So the first task will be done by the DRS. It will power on the virtual machine on different ESXi hosts. So if you observe here, it has started, it has powered on some virtual machines in 10, it has powered on some virtual machines in 20. Clear, guys? But what is the second task? The second task is to load balance the DRS environment, to load balance the cluster. So for load balancing, it will not take the decision. It will just provide you the recommendation. You need to accept it. So let us verify the second task. Again, what we will do, we will move all the virtual machines to 10. Okay, in real network, the migration and everything, it will be automated. Okay, for testing purpose, for testing, we are moving the virtual machines to 10. Then we are running the DRS. Now we are doing the live migration. We are using the vMotion here. All the virtual machines are powered on and we are migrating the live virtual machines to 10. So after 5 minutes, it will check the utilization of all the ESXi hosts, and ESXi1 is overutilized. ESXi2 and 3, they are underutilized. Then it will send you the recommendation. Move this virtual machine to this ESXi host, move this virtual machine to that ESXi host. It will not move it automatically. We'll see the recommendations as well. Anyhow, no problem. Now, again, we need to wait for the DRS to calculate the things. So it will take some time. So for our lab, what we will do, we will run the DRS manually. How to run the DRS manually? You will go to monitor. Then you will go to DRS. Under DRS, you will go to recommendations. Under recommendation, you will have this option, run DRS now. Okay, if you run the DRS, you will get the recommendation here. It will not move the virtual machines automatically. You can see it is giving you the recommendation. It is saying that migrate virtual machine 3 from 192.168.140.10 to 192.168.140.20. Okay, balance average memory load. So it is giving the reason as well to balance the memory. And the second recommendation is move virtual machine 4 from 10 to 20. So if you are agree, if you want to migrate, you will select this option, apply recommendation. If you don't want to migrate, you will ignore it. Okay, so it will migrate it. It has started the migration. Okay, and these two virtual machines, they are moved to 20. 3 and 4, I think. I forgot the virtual machine numbers. I think it was 1. 1 is moved to 20. Let us wait for the migration to be completed. Okay. So 2020. So it has moved some virtual machines. Okay, 20. Let us refresh it. Okay. It has moved VM1 and VM4 to 20. It has given the recommendation and we have approved the recommendation. Now guys, we have one more option. What is that option? Now guys, we have one more option. What is that option? If you go to the cluster, under cluster, if you go to configure, under configure, if you select TRS and if you select edit, it is having manual app option. What this manual option will do, it will give you the recommendation for powering on the virtual machine and it will give you the recommendation for load balancing as well. It will not do anything. It will just give you the recommendation. Okay. So let us verify the manual DRS automation. Okay. So again, we'll go to cluster, then we'll go to virtual machines and we will power off all the virtual machines except vCenter appliance. Then we'll migrate all the virtual machines to 10. Then we'll power all the virtual machines on. Okay, so let us migrate them to 10. We are doing the cold migration now. Alright, all the virtual machines are in ESXi1. Let us power them on. You will get only the recommendation. It will not move the virtual machines. It will not power on the virtual machine on different hosts. It will just give you the recommendation. Okay, so you can see it is giving the recommendation, power on recommendation. It is saying that place server 1 to 10, template 2 to 10 and switch 1 at 10. So mostly it is saying 10. Now here VM1 to 20, VM3 to 20, VM4 to 20. If you agree, click OK, it will migrate them. Okay, so it is migrating. So it is giving you the recommendation first and you will be you are the one, you will approve it. If you do not approve it, it will not power it on. Clear guys? Any doubt? Okay.
Yes, sir.
So affinity rule means what it will do? It will keep the virtual machines together. Let us say
Yes.
we have,
Okay. It will combine a group.
very good. We have two ESXi hosts, ESXi1 and let us say we have three ESXi hosts, ESXi3 and ESXi1 is having two virtual machines. Let us say they are a web server and database server. They are dependent on each other, right? Okay.
Yes, sir.
So these two virtual machines run together. Okay. If it is moved to another ESXi host, they should be moved together. And for high availability, for we have created one cluster. Okay. Let us say if this web server goes down, it will use the web server from ESXi2. Let us say it is web server 2 and database server 2. So what will be the affinity rule? Affinity rule will be web server 1
And database.
and database 1, they will be on the same machines. And what will be the second rule? Web server 2 and database 2, they will be on the same
On the
server.
same.
And anti-affinity rule, web server 1 and web server 2, they should not run on the same machine. Database 1 and database 2, they should not run on the same machine, correct?
Yes.
So now what we will do, we will see how to configure the affinity rule and anti-affinity rule. And what we will do, we will rename or we will create some virtual machines like web server 1, database 1, web server 2 and database 2, correct?
Yes.
So let us create some virtual machine and we'll create the affinity and anti-affinity rules. So still it is 2%, so let us cancel it and let us move on, and I will show you later what is this maintenance mode. When you got the concept why it is used, then we'll go to cluster. So let us create the virtual machines first. Web server 1, database 1. Okay, we'll go to 140.10. Let us clone these virtual machines. Let us clone VM1 and we'll give the name as
Web server.
web server 1. We'll click next and we'll create this web server 1 in 140.10 and it should be in shared storage. Okay, it should not be in the local storage. So you click next, next, finish. Let us create database 1 as well. Database 1. Okay, so they will be in 140.10. Again, it should be in the shared storage. Let us select LAN 1 only. Then it is cloning 10% is done. 95% is done. Okay, so we have database 1 and we have web server 1. Both of them are in ESXi1. Now what we will do, we will create web server 2, database 2 in 140.30. So let us clone this virtual machine. We'll go to 1.1, clone this virtual machine, and it is web server 2. And where do we want to clone it? In the US cluster, we'll create it in 140.30. Let us select learn to here. and we'll clone one more virtual machine. It is not done yet. Now it is done. Database 2. Okay. So web server 1, database 1 will create the affinity rule. Okay. How to create the affinity rule? Let us try to understand. We'll go to cluster. Under cluster, you will go to configure. Under configure, we have configuration option. Okay. Configure, then configuration. Under configuration, we have this option VM host rules, and we'll select this add option. If you select add option, you will have keep virtual machines together option, separate virtual machine. Keep virtual machines together means affinity rule, correct? So we need to assign the name here, database 1, web 1.
And web server 1.
Then we'll click add, so you will get all the virtual machines available in this cluster. Database 1, then web 1.
Web server 1.
We'll click OK. It will keep these two virtual machines together. So whenever it is moving this, the virtual machine, they will be moved together. We'll click OK. Okay. So the same way you will create the rule for database 2 and web server 2. Let us create the anti-affinity rule. Anti-affinity rule means web server 1 and web server 2 should not run on the same machine, correct?
Yes.
You will click add option, then you will select the second option, separate virtual machines. Okay, and
DB1 and DB2.
yeah, anti-affinity rule, anything, any meaningful name. Okay, DB1,
Okay.
DB2. We'll click OK. Must have at least 2 virtual machines. So we need to add the virtual machines. So we'll add DB1 and DB2. We'll click it here. Then we'll click OK. Okay, so we have these two rows. So guys, after creating this rule, DRS will not move database 1 and database 2 on the same machine, and it will not separate DB1 and web 1. Clear guys? Any doubt? Predictive DRS. Okay, let us try to understand what is this predictive DRS. So it is a new feature that is introduced in vSphere 6.5, which works with vRealize operation. Okay, we'll discuss what is this vRealize operation. So our focus will be on only predictive DRS. So what this predictive DRS will do, it will predict the load and it will make the environment ready for virtual machines. So guys, let us try to understand what does it mean by predictive DRS. Let me open the paint. So DRS we have already discussed. It will see there is imbalance in your environment, then it will take the decision. This predictive DRS, let us say you have some ESXi hosts. Okay, and in your network you have some virtual machines. Okay, so let us say ESXi1 is having web server, database server, and it is having some other virtual machines. Okay, so ESXi2 again, it is having some other virtual machines like VM1, VM2, VM3, VM4, VM5, VM6, VM7. Okay, and you are a e-commerce company. Okay, so if you are a e-commerce company, you give offers. So let us say your company gives offer every month. Okay, and let us say they are giving the offer every month of first. Okay, so every month on first, your web server and database server, they get utilized more because you are running the offer and customers, they will purchase a lot here. So web server and database server, they are being utilized. Okay, they are utilized more. What this predictive DRS will do, it will monitor the behavior of your network and it will observe that every first of every month, this web server and database server, they are utilizing the more resources. So one day before, what this predictive DRS will do, it will make this environment ready. It will move the other VMs to other ESXi host. Okay, and it will keep the web server or database server in this ESXi, or it will move the database server or web server in on an ESXi host which is having good resources. Okay, so the difference between DRS and predictive DRS is DRS will see the ESXi host. Okay, if they are imbalanced, then it will move the virtual machines. Predictive DRS, it will not see the current situation. It will predict the future. It will see that every month on first, this web server and database server are utilizing more resources. So it will make the environment ready for web server and database server. Okay, this is the predictive DRS, and this predictive DRS will use one feature called vRealize. Okay, what this vRealize will do, it will provide the data to this predictive DRS. So it will use the artificial intelligence vRealize, okay, and it will observe the environment and it will give the input to predictive DRS. Based on the input, this predictive DRS will take the decision. Got the point? What is the difference between DRS and predictive DRS?